Quarantine. Boom. We're on. Going live. Yeah. Okay, maybe I start with just my face. There we go. Okay, we're in. If you're in the chat, let me know if you can see me. Let me know if you can hear me, because we have a very exciting stream today. We're celebrating 100,000 subscribers, which is an insane amount. Yo. Let me know if you can hear, see, all good. Hello, everyone. Welcome. I like your t-shirt. Thank you, Oscar. Perfect sound. Beautiful. And what about the screen? If I put the screen on here, let's get some code. Can you see this all right? Because we're going to be going for 10 hours and I would hate for people not to be able to see. So let me know if you can see what's happening. Sound like a fellow Aussie? Yes. Movember mustache. I do have a Movember mustache. We can hear and see very clearly. Amazing. Okay, from me, YouTube is looking good. Let's get started. First, what we're going to do is we need to lay out some ground rules for the stream. So, welcome everyone. I have no idea how this is going to turn out. 10 hours is a long time, but not really, because it's only really just a day. So let's go over here and we will get, page title is, it's November the 6th where I live. It is 8 a.m. in the beautiful northern beaches of Brisbane. So I can't show you it, but I have the beautiful water there. You can see the trees, the water, the sky. It's good. It's a good day. November 6th, 100K live stream celebration. The editor is a bit small. I'll increase that. Okay, so what about this? How's the size there? Is that a good size for the editor? It's afternoon in the real world. 11 p.m. in France. Hello, everyone. Everyone leave their country flag in the chat. Let's see how many different countries we have. Okay, so that's good. That's where we're going to go. Okay, and now let's go here. How do I zoom in? Zoom in. Zoom. We're just going to use Notion, actually. Notion. Add to. That way you guys can see what's going on as well. November 6th, 100K live stream celebration. Look at that. I can't even zoom in. Open as page. We're on. Okay. So let's add a little icon. We can go party. Okay, you can all see this. Here's what we're going to do today. So we need to lay out some rules. We've got plenty of time, so we're not in a rush. Rules. So every hour equals 10 push-ups, 10 sit-ups, no, 10 squats, and let's go 10 kicks, 10 punches. That way we got to keep moving, all right? And then let's go surprises at 77 minutes in, and then that's about it for the timing wise. So let's set a timer. There's going to be a surprise at 77 minutes in. Everyone, we're going to set a timer. Timer, 77 minutes. Oh, 77 minutes and 77 seconds. Let's do that. Okay, so there's surprises when this timer goes off. That way, every hour, if we keep moving, because I don't want to be inside and sitting down for 10 straight hours. That's not me. You know that's not me. And then what we're going to build. So, let's build a full stack ML application. And we're going to build, I had this idea, something simple, because 10 hours is a lot of time, but it's also not enough time if something goes wrong, because I'm going to be doing all of this live. So let's build food, not food.app. So Who remembers hot dog, not hot dog? We'll start off, and again, if this takes less than 10 hours, we can do something else. But hot dog, not hot dog. Of course, the model to build for this is pretty straightforward. You get photos of hot dogs and not hot dogs. But we want this deployed. So I want to, before the end of the stream, you should be able to go to foodnotfood.app and use a machine learning model to take a photo of something and see if it's food. So what we have to do is, let's go to do, we need a data set. We're going to do all of this from scratch. Collect data set, and then we're going to model data set, build application, deploy application. And then after that, well, who knows, okay? So we don't have any data, we don't have a model, we don't have an application, and we haven't deployed the application yet. So let's start a GitHub repo. Who's in for that? We'll build foodnotfood.app, and then if we have more time, we can of course do whatever. But we need to build a full stack application today. Let's go new repo. We want, what should we call it? Food, not food. Machine learning powered app to decide whether a photo is food or not. Who wants to build this? Choose a license. It's going to be all open source, so you can copy it and whatever. But we have to collect a data set. Git ignore, and let's make it Python. Create repo. So there's the repo. Mr. D. Burke, food, not food. Hello, RJ Namala. Oh, look at all these flags. Thank you so much for sharing them. We have UK, we have America, we have India, we have Netherlands, another America. Beautiful. We have Poland. Thank you all so much. We have a pirate flag. Beautiful. If you're watching this from a pirate ship, hello. There's going to be some treasures out there. I am from Australia. So let's do it. Okay, we need a data set, people. Who's ready to start going? So I'm going to also probably put the Notion here. That way you can see. Copy link. Show link options. People want, that way people can see notes on Notion. Okay, everyone's ready to go now. Food, not food, see notes on Notion. And we also need an image. Save image as hot dog, not hot dog. Poland, hello, hello. Oh, the kangaroo. Egypt, Pakistan, France, Nigeria. Hello, hello, everyone. Welcome, welcome, welcome. This is going to be fun, all right? We're going to spend most of it coding, and then if we have spare time, I'll answer questions. Probably by the time I get cooked, I'll just start talking to you for a bit, and then go back to coding. I actually don't know. I have no idea how this is going to turn out, so we'll see. We're doing it to celebrate 100,000 subscribers, so thank you so much wherever you are in the world for tuning into my crazy videos. This will probably be one of the craziest. So let's go to CD food, not food. LS, clear. Beautiful, food, not food. Okay. I'm going to now add the image into there. So LS, desktop, LS. Tell me if you can see the terminal. We're going to be using this a lot. Clear, LS. We want hot dog, not hot dog. Move. code, food, not food. Now we're going to add hot dog, not hot dog, so people know what we're working on. First commit, add hot dog image. What we're going to build. So let's do this, collect data set. So I want to show you how we can, we're going to deploy it a few different ways actually. I just realized this. So a lot of people ask me, how do I work on my full stack application? So hopefully this stream is going to show you like how I would approach it. So we can do it with Gradio. We can also do it with live web app. We could do it as an API. I mean, there's 3 different ways, but I'm probably going to use it with TensorFlow JS. Why is that? Because TensorFlow JS runs in the browser, and it's very easy to if you know a bit of JavaScript, you can get it up and running pretty quickly. So collect data set, we need images of food and not food. We're going to figure that out, right? We don't have a data set. And then we'll go model data set. We want to build a computer vision model to classify food and not food. And oh, I just remembered that I've got a tweet here. This is the important thing about data sets. We go here. You all know Abraham loss function. Very, very smart person. This is why we have to build a data set. So we want data set, or no, we'll go ML model motto. Why isn't that embedding? It won't embed, that's all right. But this, very important. If you had 8 hours to build a machine learning model, we have 10. I'd spend the first 6 hours preparing my data set. Quote from Abraham loss function, which is of course Abraham Lincoln, but I've memed that. So let's bring this in here. This is what we've got to pay attention to. What if it's easy to start a machine learning model with a data set, but what if you don't have a data set? And what we're going to build, and we want, let's get in that image of hot dog, not hot dog. Choose image. Where'd hot dog, not hot dog go? Code. Okay. Caption. What we're building, except for food, not food. A nice and simple app, that's what we want. So full stack machine learning application, surprises at 77 minutes in. Every hour, someone keep a track of an hour. And thank you for, this is going to be saved, yes, you're right. You're good in JS. Is it easy to learn machine learning in JS? Yes, of course it is. I'm about to show you. I'm terrible in JS, but we're going to figure this out. Tweet. Ah, thank you. There we go. Delete. So now let's go back to where we were. I'm going to get out of that and put in the GitHub what we're building, except for food, not food. Let's go image source equals did that not push? Okay, we're on. So now let's figure out how we can build a data set. We need to model data set. We need to build application, simple HTML with JavaScript, and then deploy model. We've got a few options here. Gradio. Gradio is probably the easiest. I'll show you how beautiful that is. Once we've got a data set though, we don't have a data set. And then there's also, we're going to do TensorFlow JS. And then maybe an API. So let's do that. We're going to deploy a web app and implement ML ops. Dark mode, please. Maybe I should turn on dark mode for the stream. System. Dark mode. Boom, we're on dark mode. Why didn't that go into dark mode? Hey, this is not in dark mode. Appearance. How come this is not changing? That's all right. Nothing's in dark mode. That's all right. So let's figure out how we can collect a data set. That's what we want to do. So we need a way. Let's go. ImageNet's a good downloader. Download ImageNet. Download from ImageNet. We need images. So we don't want the full ImageNet dataset, of course. Who knows how to turn on dark mode in VS Code? Why is that not dark? I just restarted it. That's all right. We can go light mode. Control P theme. Thank you. Theme, no results. Ah, here we go. There we go, we're on. We're in the darkness, people. Welcome to the darkness. Welcome to the darkness, my friends. So let's collect a data set and build a model first. Do I have... I'm trying to think. I should train the model on my deep learning PC. So let's connect to that. Opening remote. We want clone git repo. Food, not food. and I have a TensorFlow environment ready to go. Open. Conda. Beautiful. So we have hot dog, not hot dog. And we need to find a data set though. ImageNet data downloader. So that's what we're going to do now. First things first is collecting a data set. So when I make timestamps for this video, I'm going to say timestamp, and then that way I can search the text and say timestamp that collected data set is at this timestamp. So we're going to, for images of not food, download random images from ImageNet. And for images of food, we can use Food 101. So we're going to combine two different data sets. Food 101, random subset of images from Food 101. Hey Egan, how are you? It's 1 a.m. in Turkey. Oh, no worries, my friend. Yeah, this video will be on the channel. For everyone is who can't join into the live stream, no worries. This video will be on my YouTube channel once it's finished, and I will put timestamps in. There'll be a lot of timestamps probably. Build a computer vision model to classify food and not food. So this is what we need. We need images of not food, and we need images of food. So let's go to here. Is there ImageNet downloader dataset? This is what we want. ImageNet datasets downloader. You can create datasets from subsets of ImageNet by specifying how many classes you need and how many images per class. Beautiful. This is achieved by using URLs provided by ImageNet. Wonderful. Okay, so the following command will randomly select 100 of ImageNet classes, which at least 200. This is what we want. Okay, so we want to build a not food dataset from each selecting class. So let's go ImageNet class list. How many foods are in here? Food. Food market, grocery store, market. Okay, what we could do is we could download this and then randomly select, say, 500 classes or something, and then delete the ones that are food. Because that way we'll have a data set. Is banana in here? Banana. I see. Fruit. Jackfruit. Pineapple. Apples. Okay, so that's what we need. We need some data from ImageNet. How about we do some data processing on this? So, raw. Let's start up a Python script. Hello from Pakistan. Hello from Peru. You're looking good, bruv. Thank you, Adam. I appreciate it, my friend. Ashik, it's 3:45 a.m. there. Well, I appreciate you joining in, legend. Banana, banana, banana. Wait, why is this? Download NVIDIA compute. Hey. I don't want to get that. Why did that just download a CUDA repo? We want, let's just download the zip of this. Download zip. What's in this zip? Why not just download non-food images from the web? Well, think about how many different non-food images we'd have to download. Whereas we can just use this, ImageNet. So I'm going to need to copy this over. So let's move this into downloads. Actually, we'll move it to the desktop. So we have ImageNet 1000 class IDX to labels. So yes, Ashik, I am connected to the deep learning PC via SSH. You can see that there. This is running on my deep learning PC downstairs. Oh no, I don't need the NVIDIA SMI. Hello from Saudi Arabia. Hello from Australia. There we go. We have a NVIDIA Titan X GPU ready to go, but we have to do some data processing first. So let's get to terminal. We'll CD into desktop. Oh no, we can just commit it. So move ImageNet, and then we want to move this to code food, not food. So now we're going to just add the ImageNet classes. We'll commit this. And then we can just pull that down on, we could have secure copied that SCP, but we're going to just pull. So now we've got ImageNet classes here. Beautiful. Okay. So now we need to write some Python code we want to get all of the classes in here that are not food. That way, we can build a data set, we can download images from ImageNet that aren't food. So if someone takes a photo of the not food class, it will recognize it as not food. Hello from Florida, hello from Iraq. Oh, well, Ashik, you just wait. The deep learning PC is going to be used a whole bunch. We have 100 people watching. Thank you so much for tuning in. Okay, so let's start to write some code, and we can just probably manually go through all of these classes and delete them if they're food. Does that make sense? And then we can get all of the ones that are not food, and we'll download 100 images of each, and that way we'll have a pretty big data set of like 10,000 images. And of course, this doesn't include everything in the whole world, but that's the idea of our model, is to learn a probabilistic relationship between what a image of food looks like and what an image of not food looks like. So let's create, if you want to replicate this, this will all be on my GitHub. And now let's open up this. Data exploration, we want import pandas as PD, import numpy as NP. Import CSV. reinstall. Hold on. Kernel, I want... Okay, there we go. We want with open ImageNet copy the path. Dot read bytes as f dot read lines. We want ImageNet classes equals a list, and then f dot read lines. Is this going to work? Might have to look up how to read a text file. ImageNet classes dot append. M1 is going great. Oh, did that work? Beautiful. Okay. Maybe we don't want to read it as bytes, so we don't have byte strings. There we go. Okay. Read lines. But we don't necessarily want that. We've got each one is a line. Or we could just go ImageNet classes equals f dot read lines. ImageNet classes, beautiful. This is a Jupyter notebook. This is a Jupyter notebook running in VS Code. So there's a better way to do this. Let's look that up. Python, how to read in dictionary from TXT. Dictionary from a file. File open, dictionary string. AST literal eval. Is this from the Python standard library? Okay. We just want read. f.read. And then okay, beautiful. We've got a list of ImageNet classes. Now, who knows a good way to explore a dictionary? In VS Code, yes, you do get to press tab and get suggestions. Look at this. There we go. VS Code is very good. Hello from Ivory Coast. I don't even know what that is. Let's look up Ivory Coast. Ivory Coast. Hello from Brisbane, Australia. Ivory Coast. Wow, West Africa. So good to see you. Thank you for joining in. That's amazing. What does Ivory Coast look like? Wow, that's beautiful. How do you say this? Côte d'Ivoire. Sounds French. Okay, we're getting a bit distracted. Let's go back to the code. So we need a way. Let's go through this. And how do we edit a dictionary? I mean, I turn a dictionary into, I want to remove, let's loop through this. So for ImageNet classes, so we want for kv in ImageNet classes dot items. If v dot contains banana, print k. String has no attribute contains. Python check if string contains string. I thought find. Does Python have a string contain substring? Oh, in. I'm too used to writing pandas. If banana in the 954. Okay. So, maybe we just go ImageNet food classes. No way. This guy, Swidashar Kothar, has built food not food. Distinguish between food and non-food. See, this is the beautiful thing. Okay. How did they create a data set? VGG 16. How did they get the data set? Food image data set. Beautiful. Look at this, team. We have so many different options. Okay, well, that link is dead. Look at that. To develop an app that can distinguish between food and non-food, we're going to extend this. You know what? We're going to come back to our friend Swidashar Kothar at the end of this, and once we've built it, we'll link him the app, hey? Come back. He built the model but didn't build the app. To do, come back to, how do you spell his name? Said Ishwa to say we've built the app. We're going to come back to this lovely person and say, hey, you know what? Thanks you for getting that started online. We're gonna build upon it. So what other foods are in here? Apple. Pineapple. Is there meat in here? Meat. Egg. Chocolate. See, this is how you got to go through crafting a data set. So let's go Python list of common eaten foods. Nope. Hello from Turkey. It's French, could pronounce it as Cour d'Ivoire. I'll probably get all this wrong. Hey from Colombia, 2 people from Colombia. Thank you so much. What do you think about the new MacBook Pros? Will first M1 generation be enough for beginner, medium, DS, and ML user? Yeah, for sure. The beginner M1 is a fantastic machine. I've got some of the new ones on order. I'm going to test them out too. So Python, here we go. Closed. Oh, here we go. NLTK, you can get, what does this do? This is beautiful. We're just going to combine a whole bunch of different data here. So USDA, food data. Oh, we could work through this. I've already got this data downloaded. Let's try the NLTK method and then we'll come back, hey? We'll get this, the food, sysnet, and wordnet. So let's go food, wordnet, subset, downloader. Congrats on 100K, thank you so much. Tray review, that's what we're doing. We're getting a data set of only non-food items. An M1 with 16 gig of RAM is perfect to get started. Full, fast, multi-threaded download of images from ImageNet. Okay, here we go. So let's install NLTK, hey? NLTK, WordNet. Okay. Let's do this. Seeing 8:43 a.m. freaked you out? Yeah, it's nice and early here. Let's try this out. Let's install NLTK, hey? So, what's the recommended? Installing NLTK. So we need to install NLTK. Nice and quick. And we're going to download this is a very nice website. Okay, so let's just save some steps. Log downloaded ImageNet class list from GitHub. Downloaded and installed NLTK. Want to get non-food classes from ImageNet. Installed NLTK to get to try and get a list of words associated with food. This is our log. Clear. ls. We have, where's the ImageNet classes? I'm just going to put this here. This is so someone can replicate what we've done. I want the code to be, it's all going to be open source, so I want someone to be able to replicate what we've done. So let's now go back and figure out what this does. So this is going to be, we'll make it here. Food names from NL2K. Hello, Manus. How are you? Vamsy thought I was in California. No, I'm in Brisbane, Australia, my friend. Land down under. So, from what I understand, do I not have NLTK? No module named NLTK. We're going to have to do some environment refreshing. NLTK. Hey, why didn't that install NLTK? Requirement already satisfied in site packages. I want to conda how to install in current env with pip. It should install yes, okay, this is what I want. Conda install pip, that's what I need. There we go, okay. Clear, and now we want pip install NLTK. Requirement already satisfied in site packages. Okay, pip install conda env list. We want it in the current env. Wonder if I can just install it from here. Pip install NLTK. Requirement already satisfied. I don't want it in there. Oh, there we go. Import NLTK. No module named NLTK. Classic. Oh, I had to restart the kernel. Machine learning. Insist on neural network. So a neural network is just a function estimator. Machine learning in a nutshell is you use machine learning to identify patterns in data or turn data into numbers, whatever data is. Could be words, could be images, could be videos, could be text, could be anything. And then you use a machine learning algorithm to turn that data into numbers, or a pre-processing algorithm to turn that data into some numerical representation. Then a new machine learning algorithm, such as a neural network or whatever, will go through those numerical representations and find the patterns in there. What the patterns are, you define. And what the patterns are that the machine learning model actually figures out, it learns those patterns. Okay, so let's see. Oh, look at this, team. There we go. Okay, we've got a list of classes. This is wonderful. Let's go NLTK corpus. What's wrong with this? It worked. Turn the warnings off. So look at this. We've got a list of foods. This is wonderful. How long is this list? I need some space to code here. So wordnet.py discarded redundant search for that's all right. Food list. Oh, look at this. Now we've got a list of food items. 1,600 food items. Let's have a look through these. So now we've got a list of food that we want to filter if the ImageNet class has any of these in it. Look at this. Tabasco, chips, mashed potato, cut of pork, delicious, takeaway, pullet, chocolate bar, grey mullet, gammon, yogurt, brat. Okay, this is wonderful. We have a list of foods now. So what we're going to do is, got a list of foods. Now, we have a list of foods. Now to filter the ImageNet dataset classes and remove any class that contains a food. So we can download images of non-food from ImageNet. We're building a dataset from scratch here, people. That way you can replicate this whole thing from machine learning model to dataset building to everything. So let's have a little bit more of a look here in our data exploration notebook. We have a food list. Let's just view the first 10. So we have 10, and let's check if banana in food list. True, there we go. There's a banana is our sanity check. Check for banana in food list. So now we want to filter the ImageNet dataset. So ImageNet dataset, I believe, doesn't have, okay, we need to let's strip the strings from here. We'll lower them all, so they're all lowered, and we'll get rid of the hyphens and any punctuation. I think there's only hyphens and underscores. And the same thing we'll do with this. We'll get rid of the underscores and lower. So filter food items out of ImageNet list. Can I show time to time your RAM usage with Activity Monitor? Yes. This is not on my M1. This is on my MacBook 16-inch. So memory, I have 64 gigs of memory on here. But remember, I'm streaming and doing a whole bunch of things. And it's also going to use more memory if you have it. So yeah, I have, like, Dropbox uses it a lot, and Windows Server and whatever. But that's all right. Filter foods out of here. Thank you for the comment on the Mo, Siobhan. I appreciate that. So filter food items out of ImageNet list. We want to have for food item in food list, string, no, food item dot lower all the text. No, print. Okay, and we want dot lower, and we want to strip Japanese plum. Hey. No. What's the method? What's the method to break a string on a certain thing? Who knows this? If you're not really sure where to start machine learning, you can go to my blog and go search for this, Daniel Burke, 5 steps to ML. Right, there's a lot of shit out there on machine learning or whatever. This is pretty straightforward. And split, that's it, thank you. And otherwise, look up the machine learning roadmap. Thank you everyone for helping me with Split, machine learning roadmap. Look at all this. Look at all these ads that are above me. Above there, above there, above there, above there. But look, my GitHub, machine learning roadmap. Number 1. We've got ads. All these ads are above my post. My post is machine learning roadmap, number 1 on Google. So thank you everyone. Let's use the split command. The perfectionist, am I getting the new MacBook Pro? Well, I've got some on order. I'm going to test them out. Split. Okay, there we go. And we want... So let's remove punctuation and lower. We want food list equals food item dot lower dot split for food item in food list. Okay, and now we need to create a list of item for food item for sublist in does this work? Food. Nope. For sublist in no. Food for food item. That's what we've got to do. A list of lists. Food for food item. I always get this mixed up. Python create a list from list of lists. It's a sublist. The item for sublist in T flat list equals food item for food list No. I got an idea. So we've got food list there. Hey, what happened there? So now let's flatten it out. Flat. So flat food list equals food for food list in food list in food for food sublist in food list. Int for did we make it? We made it. Okay, there we go. So we've got flat food list. We've got a list of foods. Now let's do the same for our ImageNet. I'll make this all nice and clean before it's uploaded. But we've got a flat food list. But we only really want to see the first 10, don't we? And every time we rerun these cells, it's going to override variables, so that sucks, but that's okay. I really love you says, I'm a noob and I hate guys who work in machine learning. Oh, that's unfortunate, man. You're in the wrong stream. So we have a flat food list. Now let's, we want ImageNet classes. So for KV in ImageNet classes, if v dot, we need to split v dot lower in flat food list print k. What's this going to do? We need items. Hey, there we go. If v dot lower so let's go check ImageNet classes for foods. So this is our list of ImageNet classes, and we want print KV. What does this look like? Hen, quail, partridge, goose, snail, hare, sorrel, honeycomb, pinwheel, plate, pretzel, broccoli, cauliflower, cardoon, mushroom, strawberry, orange, banana. So the banana sanity check is there. That's beautiful. Okay, let's now, but V is also multi-level strings. So we actually want print v dot lower, and we want split on comma, yes, and then we want the items from a list. How do we retrieve the items from a list? Or maybe we can do a straight up comparison. Will that work? No. Okay, I need to go to the bathroom. I'll be back. Dan, reflecting on your time in ML, what's the biggest highlight and lowest point so far? I'll be back in a second and we'll answer that question. And MoveNet for BJJ. Oh, that's an interesting one. One sec. Okay, welcome back. My Muhammad says, I've always wondered how to make do online using ML. What's the easiest path? Well, there is no such thing as the easiest path. Well, it's like every path is easy if you choose your own. So I could sit here and talk at length for how to do it, but my only way is to actually just do it instead of thinking about it and talking about it out loud. This is like, we're literally doing machine learning online right now. So that's how I do it, is I just think of something that I'd like to build and I build that thing. But Siobhan said before, I really easily get overwhelmed when I try to do ML project. Any advice or tip? Just keep going till you get better. Who knows? I'm doing a live ML project right now. I might get overwhelmed, so we'll see. Siobhan, reflecting on your time in ML, what's your biggest highlight and lowest point so far? Highlight is like right now. Look at this. How cool is this? We can make machine learning apps to 100 people around the world and share the code, make it open source. What's not to love about that? Is machine learning course by Andrew Ong still relevant in 2021? Yes. Most of the courses online these days are pretty good, right? So like, that's the beauty of online. It like filters out the ones that are shit and the ones that are good pretty easily. So if a lot of people are doing a course and they rate it pretty highly. I'm not saying anyone's courses are rated pretty highly, but someone might be. You know pretty quickly whether it's good or not. So that's the beauty of code as well. Code either works or it doesn't. And if it's math, it either works or it doesn't. So you can pretty quickly find out if a course doesn't work, if the code doesn't work. So we're going to go back to coding. I'll get more Q&A later, but we're on a bit of a roll here. So I really want to start downloading a data set because I don't know how long the download is going to take. But for building projects, just do it. You're far smarter doing than you are thinking. For doing machine learning online, literally just you overthinking it. Just start doing it. Add code to your GitHub. Write stuff on your blog or Medium or whatever. That's how you do it. So we need a way to compare the strings here. So what's the best way to extract items from a list in Python? Get items from a list. So I would like to compare if... This is what I want to compare. You all can help me with this. This is what we're going to do. This is a community-driven project. We have this string. I want to compare that to the flat food list. So flat food list looks like this. I want to know if this item is in... That's what we could do. So we could get the ImageNet items, and then we've got the... I want to unpack. How should we do this? Python unpack a list. String 1. If in doubt, code it out. String 1, string 2, for... I will save the stream will be on my YouTube channel, yes. String 1, string 2, so we're doing some basic string manipulation here, people. Remember, Abraham loss function said, if you're building a machine learning project, spend the first 6 hours preparing the data. So we want string 1, string 2 in string 1. So that's not going to work, right? So... not list. We want to extract those strings. So maybe we break this down. Does it understand what I'm trying to do? So let's write this in pseudocode. Thank you, Hatan. I appreciate that. I'm glad you like my shirt. So look at ImageNet classes, and then we want to get value from ImageNet classes, string, and then we want to see if value appears in flat food list. Intersect. Intersect could be a good one as well. Oh. Can we see weights and biases later too? Yeah, let's do that. We'll get the whole shebang. We'll use weights and biases to track our experiments. Good idea. So let's try that, hey? That's a good idea. Set. I want to also strip. Will this work if I go get rid of spaces? Strip. List has no. I need to remove the strip. Okay, that's what we're going to do. We're going to create a list of let's go print no space for space word in v dot lower Okay, there we go. We've got a way to do that. Now we can turn that into a set. Let's go. A list comparison. That's what we could do. Maybe we do that. Intersect. Let's try it up here. Set. Someone said intersect and they are amazing. I'm pretty sure you're going to be right. Intersection. Nothing. This needs to be a set. Huh? Then iterate over the set. Am I not doing this right? Python set intersection. Oh, do I need to assign it to a variable? What's happening here? Just join. Not entirely sure what you want to do. Do I need to turn this into a... Hey, there we go. Okay, my set code. I've got the itchiest nose on earth. Oh. Marlo, guys, what's going on? There we go. We got an intersection. You need to turn things into lists first. So now what we could do is a set. So let's go print. We're going to get ImageNet class list equals this. Oh, we'll go set. ImageNet class set. Someone said, whoever said, thank you, big shout out to whoever said use a set. Didn't even think about that. See, that's the power of Python's built-in type. Someone has thought about this before. There we go. Okay, we got a set. Now, let's go. We've got a flat food list, and we're going to go ImageNet class set dot intersect in flat food list. Well done, team. Look at that. Okay, let's can this printing out. What do we get? Oh, look at that. That's what's up. That's what's up. Okay, now we need this is for foods. So ImageNet food classes. We want to filter these out. Equals an empty dictionary. And now let's create this. ImageNet food classes equals, we want key K equals V. And now let's have a look at ImageNet food classes. There we go, team. We're on. Fish on. Fish on. So now we've got our ImageNet classes that are up here. This is the full list of classes. And this is all the ones that are related to food. Well, not really, actually. How many we got? Length. We have 49 classes that are from ImageNet with but I feel like we can get rid of some of these. The manual filter, that's what we might have to do now. So I wonder what the best way is to filter a dictionary. Let's have a look at this. We're going to use our best judgment here, team, to what classes shouldn't be there. Hen, we could use hen there. Ruffed grouse. What is ruffed grouse? Oh, a bird. Well, is that food or not? We need to discuss this on the stream. Is a ruffed grouse, is that food or not? Or is that a bird? Because technically that is food. But let's say this is, are we classifying this as food or not food? If you took a photo of that. What do we reckon? So let's remove non-food classes, manual, sort. It's food. We can eat it. It's a food. Okay. Depends on the culture. It's a food. We're classifying as it a food. So going through ImageNet food classes manually. Equals, now we're going to create a list here. Quail, partridge, goose, snail, spinny lobster, crayfish, hare, sorrel. Almost reaching 77 minutes. Can you hear me breathing too loud? Should I turn the mic down here? It's a product of food. Okay, it's going to be food. Chime, bell, gong. Well, that's not a food, is it? So 494. Birds equals food. Yes, you're right. Salmon, bluejack, yes. Puffer, pufferfish, blowfish, bow tie. A bow tie is not a food. So now we're going to have to get a little manual. That's okay. NLTK has done very well for us so far. Chime belt. Frying pan, fry pan, skillet. Now, a frying pan on its own is not food. So that's not food. Honeycomb, hook, claw. Lighter. 626. Lighter, you're right. Pinwheel. Pinwheel is not food. Pot, flower pot, no. 738. Refrigerator, icebox. Well, it has food, but it's not actually a food. Plate, that's an interesting one. No, plate is not a food. Bagel, hot dogs, there's hot dogs. What's a cardoon? Who knows what a cardoon is? Cardoon. Oh, is that a food? Sunflower family, including the artichoke. What the heck do I do with a cardoon? Edible? A celery stalk. Okay, popular ingredient in Italian dishes, so it's eatable. Eatable, edible. These are all foods. Cliff, drop, drop off. I don't know what that class is to do with, but let's filter it out. If in doubt, filter it out. These are the classes we don't want. Promontory, headland, no. Let's go 976, and I think that's going to be it. So now, you're right. Pigs are food, but dogs are not. Oh, look at that, team. You know what time it is. Well, maybe you don't because you're joining in, but you know what that is. That's 77 minutes. We now have some surprises. So let me just leave a note here of where we're up to. So that's non-food classes manual sort. We have tea as well. Thank you. Have the fabulous Georgia bringing me tea. Thank you so much. We have some surprises to give away, but I'm going to leave a little note here. Thank you. Thank you. We're going to leave a little note. Next, we've got non-food classes. Is remove non-food classes manual sort from ImageNet food classes. And then we want to download ImageNet. No, then we want to filter non-food classes from ImageNet food classes, ImageNet classes, and then download non-food classes from ImageNet downloader. All right, that's what we're doing next, but now we have some surprises. So thank you all so much for joining in. I need to go to my website. Oh, not Affinity Photo. We'll quit that. Cancel. I have a blog post that I'm about to publish. So if we go to Safari, site, let me just publish this so then you can all have the link. We have a 100K subscribers live stream celebration post, which is now public. Everyone should be able to go to this. If you go to www.mrdburke.com/100K subs, we have this. So I'm going to link this into the chat. This is my way of saying thank you to you all. So we have 100K subscribers live stream celebration. You found the page of magic. So celebrate 100,000 subscribers on YouTube. I'm doing a 10-hour coding live stream. You might even be watching right now. Thank you so much for tuning in. There are some goodies to go away. So we have 50% off the first month of access to all Zero to Mastery Academy. There's 100 codes there. The first 100 people to redeem these codes will get 50% off the first month. Beware, for all of these, if you do not cancel before the month ends, you will be charged full price. So there's link number one. You also get the first 100 people to sign up to Coursera's Google Data Analytics Professional Certificate the month off for free. Is this the right link? Look at this. Special offer for Daniel Burke fans. First month free. Okay? If you sign up, there's 100 passes to this. The link is at www.mrdburke.com/100K subs. We have this. And then we have 52% off my book, Charlie Walks, if you use the code 100K. So all of these links, we have the first 100 for each. So 100 codes here for ZTM. We have 100 free passes for the first month of Google's Data Analytics Professional Certificate, which has been taken by 400,000 people around the world. If you want to learn data analytics, this is one of the best courses, and you get the first month for free, so you could do the whole thing for free by Google, and 52% off my book. So make sure you go check that out. It's for the first 100 people, okay? Once the codes are out, they're out. So check out that page. If anyone wants it, you're in. And I'm going to put this in the description of the stream as well. That way, edit, and then get the free stuff / surprises here. So the link's in the description and the link is in the chat. Thank you all so much for joining in. If you have any problems, let me know. But there we go. First month free, Coursera's Google Data Analytics Professional, 50% off the first month of all Zero to Mastery Academy courses, and 52% off my book, Charlie Walks. So go and enjoy that. That's the 77-minute surprise. And of course, it's over an hour in, so we have to do 10 push-ups. What was the rules? We're going to make this fun. We're getting back into code in a second, but we have 10 push-ups, 10 squats, 10 kicks, 10 punches every hour. Who wants to join in? Push-ups first. Now squats, I just realized you can't really see me. Why 52%? Because if you add 5 plus 2, it equals 7. 9, 10. I don't know if that was 10, but we'll call it 10. Now 10 kicks, 5 each leg. We need to keep moving. Otherwise, we'll be sitting down for far too long today. 10 kicks, 2, 3, 4, 5. Now 10 punches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One for good luck. Okay. Now another hour timer. Oh, I got my breath up. That's good. Another hour timer. Go and check out those links. 50% off ZTM. First month free on Google Professional Data Analytics. And my book is 52% off. Valid for the first 100 people only. And because you're here live, you get first pick. Okay, back to the code. We have, in another hour, we're going to do more moving. So, next, we wrote ourselves some notes. We're still building the data set. Now, this is important. Back to Abraham Loss Function's saying, we haven't built any machine learning code here yet because we're building a unique project And that, like, the way we need to build a model is we can't build a model without data. So this is what we're working on. We're still collecting a data set. So here, food breaks will come at some point. So Hatan is saying, asking for bank account. So you'll still need, on both websites, Zero to Mastery and Coursera, you will need to enter your credit card. Again, read the T's and C's that I've put on here. If you don't cancel your subscription by the end of the first month, you will be charged for the full price for the second month. That's the way these platforms work. I don't manage the payment system. So keep in mind, if you want the free month, cancel before it refreshes. So you can have 50% off the first month, or you can have the first month free. You do need to enter a credit card, but if you just want those first months, cancel before it renews the second month. So that's your warning. Let's get back into code. As for the book, you just buy it, you pay the price, and you own the book. Like, the book's yours after that. I'm going to refresh this tea that the lovely and beautiful Georgia bought me. Thank you. Okay. So we need to now, we have ImageNet classes. ImageNet classes, there we go. But we want to remove all of the non-food classes. So ImageNet food classes. Let's now update ImageNet manual filtered food classes. We'll create another variable here. We'll turn it into a dictionary. So we've got a list of keys that shouldn't be in our ImageNet food classes. So let's have a look at this. ImageNet food classes. We want just the first 5 so we can see what's going on there. Slice, unhashable type. What's going on here? Oh, it's a dictionary. So let's turn it into a list. And we're going to turn this into that. First 5. How do you view the first 5 items of a dictionary? That's all right. We can work with this. We'll work with this. So now let's ImageNet food classes, and so for KV in ImageNet food classes dot items, if K in, we have keys of non-food classes manual sort. I'm going to get rid of that now. So we're on here, team. In there, if K in here. No, if K not in. That's what we want. Don't want keys that aren't food from the manual sort. What did I miss? You were taking mock tests. You want a chic. We've got giveaways here. So this is the giveaways. www.mrdburke.com/100k subs. There we go. Thank you, Giorgio. Dictionaries are not ordered. You're so right. We want here. ImageNet, manual filtered food classes, K equals V. And now we have, we're going to put some markdown here. Remove the manually filtered food classes from ImageNet food classes. Some classes in ImageNet food classes weren't actually food. So now we're going to manually filter them. Beautiful. So let's have a look at what our new dictionary is. Wonderful. And we've manually filtered the food classes now. So this is the ImageNet food classes. Length. Wonderful. We have 39 manual filtered classes. Tea is deliciosa. You can turn the key or values into a list and splice it. So now what we have to do is we have ImageNet classes. Get list of food and non-food classes from ImageNet. So now what we want to do is compare ImageNet manual food classes from, we still have ImageNet classes. This is the overall list. So now we want to go, hey, ImageNet non-food classes equals a dictionary. And so for every key that's not in here, let's get a list of those keys. Get food class keys. Now this is very hacky, right? But it's working. We can refine this later if we wanted to. Dot keys, and we want we want a list of keys. Food class keys equals that. Let's have a look. Food class keys. We'll get the first 10. Okay, wonderful. So now we want ImageNet non-food classes is going to be, what is the length of our, how many classes do we have? Equals, this is some simple data filtering here. Hello, that's not it. ImageNet classes. We have 1,000, yeah. So now we want to remove the ones that are non-food. So that, and we go for kv in ImageNet classes dot items. If k not in food class keys, ImageNet. So we've got some just basic dictionary and manipulation here. Non-food classes. Could this be optimized? Yes, it could. That might be an extension for one of you watching at home. K equals V. Now we have a dictionary now of non-food classes. Look at that, team. Okay, and now let's get, how many are there? 961. That makes complete sense because we have what? We have 39 food classes. So we've removed those from the list. So now we have a list of ImageNet non-food classes that we can download to create. What are we working on creating? We're working on creating images of not food. And food, images of food can be from ImageNet photos that are food. So now we have two dictionaries. One is ImageNet manual filtered food classes, and one is ImageNet non-food classes. So how about we filter the strings that are in here as well? ImageNet non-food classes. Of course, there's going to be some overlap here. There's probably going to be, this is not a perfect data set for sure. We could probably fix that out. Chickadee, I don't know what a chickadee is. What is a chickadee? Who knows what's in ImageNet? Is that food? That's probably food, but we're just going to leave that in there for now. We've done enough filtering. What tea is it? We have, this is pu'er tea. So pu'er tea is a Chinese tea, a Chinese black tea, and it's one of my favorites. The Chinese really figured this out. Pu'er tea. That's what we're having. Images. It comes in cakes like this sometimes, but this is, yeah, this is what I'm drinking. Pu'er tea with some delicious milk. And sometimes a little bit of honey in there, you know? But let's go back. We're getting distracted from coding here. Let's lower these strings and remove any, or do we want to lower them? Let's just leave that at that. So now let's see how our ImageNet class downloader works. So let's write in Notion log got list of food classes and non-food classes from ImageNet. Now to figure out how to download non-food and food images from ImageNet. Random samples, and can also create a food dataset, food image dataset from food 101. Random samples of images from different classes. How many images of each do you think we should have? I reckon 10,000 of each is a good idea. Someone is asking, oh, hello, greetings from Europe. You have to sleep soon. That's all right. The stream will be on YouTube later. I'm going to be here for a few hours. Michael, really love this stream. Keep at it. You're my motivation while I'm coding as well. Thank you so much, Michael. I appreciate that. I've been thinking about this for a while, actually. I've been streaming on Twitch, but should I just move it to this channel and then just keep it all in one place? And then I just have a live stream playlist where all of my streams are in one place on YouTube? Will that clog up the channel? Or is it better just to have everything like separated on Twitch and whatever? So let's get rid of this, 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 get rid of this. Data downloader. Okay, here's what we want. The following will randomly select 100 of ImageNet classes with at least 200 images in them and start downloading. So the class list here, we need it in where I list every class that appear in ImageNet with the number of total URLs. This CSV. Maybe we should have filtered that on that, but that's all right. We should be able to map things. Okay. Class ID, class name. How many is this? Okay, we could have filtered things off this, but that's all right. That's probably what we should have done. We can adjust it. Okay, this is beautiful. I like Twitch and would prefer separated. Yeah, I think Twitch is still the better way to go. Twitch and then upload it to the VOD, to the other channel. So, okay, this is probably a better list that we can filter on. Let's come back. This is a long list, but that's all right. Food. Well, food is a class in here. We obviously want to filter that out. We need the ID. I'll be back in a second. I need to pee again. Is it enough for your course for machine learning and data science, or you can take whatever you want. Follow your curiosity. My machine learning and data science course, do you need to take that? Of course not. Like, this is this is the thing. There's a lot of resources out there, but it's usually best to just pick a couple and practice on those. So if you want to do Google Data Analytics, do that. If you want to do my course, do that. Try it out. That's the beauty of like having a month free. You can see if you like it. If you don't, cancel it. We're going down. YouTube is a source of income, but like I don't rely on it. So maybe we should filter on these because these have the keys, but that's all right. So let's I should have really just read the docs on this. But why read the docs when you can spend multiple hours just figuring stuff out? Words.txt. Too big. Classes in ImageNet. Okay, let's filter these out. Let's get this CSV file. Raw. Can we read this straight in with pandas? It's all right because we've got this. We need the codes. I didn't realize that we needed the codes for downloading. See how this takes in a class list of different codes? Let's read the script. Okay. So it takes in a class list. Thank you, Aditya. I appreciate it. Hatan, if you want to do the Google Data Analytics course, you can do it. But if you've already done mine, you probably don't need it. Any tips on starting a YouTube channel? I make the videos that I like to watch. Need ImageNet keys. That's my only advice for starting a YouTube channel. Need ImageNet keys. Turns out the download script downloads using ImageNet class keys. For example, so we need to map class keys to the classes that we want. Let's download this CSV. So we want, let's put it in here. Import pandas as CSV. df equals pd. We can read CSV straight from the URL. Straight from the raw GitHub URL. That's all right. Now df.head. Okay, there we go. And now one of the beautiful things about VS Code as well is I believe it has a viewer. Variables. We can view the data frame. Look at this. Hey, look at that. That's cool. Food. Okay, there we go. We can filter out anything to do with food. But we still have our food list from NLTK, which is beautiful. So let's filter this out now. See you, Tray Review. Thank you for joining in. I appreciate it, my friend. So now let's get the DF food list. We want the flat food list. Once we build this data set, team, the model building will be the easy part. So we want to now filter the pandas data frame if any of the class names contains, let's go df class name. What do these look like? Vitamin C. Okay. Planking. So this is pd.read CSV. Oh, my bad. That was a mistake. Import pandas as CSV. That was a mistake. Class name. Lower. Okay. And is there any spaces in these? I think we can get a pretty good filter. Look, it's not going to be perfect, but it's going to do. Food list. So we want to now I'll lower all the strings. No, actually, let's go get the length of the DF. Okay, 21,000 rows. Let's see how many this filters out. So, filter data frame from food classes. That was a glitch. I don't know why it worked, but yeah, Giorgio is correct. I imported it earlier as PD. So df non-food equals df filter on df class name. No, not contains. We want to make this not. Class name dot string dot contains dot string dot is in. float. No duplicates. We've got PD as PDs here. Pandas as PD here. So it seems that there's bad operator time, not for float. Ah, how many nans are in here, you reckon? Okay, so we've got a few. Remove nans. Okay, there we go. We're on, team. Fish on here. So we got to remove all the ones that have food in them. So is food... Once we build this model, we are on. This is going to be a beautiful model. Okay, there we go. String.lower.contains. Let's lower all the strings. df equals there we go. There we go, df non-food. How many did we filter out with that? $21,820. So we filtered out 19 classes with just the food string. So string now we want to filter out there we go. Okay, so we filtered out a bunch of foods here. So this is the non-food classes. So we filtered out about 1,000 with that. So that's good. But now we also want to... We also want to... Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, Let's go, because these class names, df class names have underscores and whatnot. So that's isIn is a perfect match. So we want let's go data frame filter column by strings in list. Yeah, isIn. isIn seems the best way to do it. Have I ever used PyTorch for projects? Not for a project, but I'm going to start using it actually. I think we can work with this. Yeah, here we go. This is what we want. So we can standardize the text here. How about we change the phishing, troll. I think we've removed enough classes actually. It won't be perfect, but let's start to download some data, hey? So this is so now we have two data frames, df food and df non-food. There we go. We have 1,000 different classes of food. I'm pretty happy with that. df food. But now we can remove some of these. Which one shouldn't be in here? There's probably a lot of these that could be removed. But let's start to download some images and then we can plate. Okay, that's close enough to just being all food. So now what we can do, hey Mehmet, how are you? Siobhan, Jeremy Howard's in Brisbane. Yeah, I believe he lives, lives somewhere in Brisbane. Not sure where. So we can remove things like ball. Okay, so that's going to be to do. Because if you take a photo of a ball, that shouldn't be in there, should it? Ball. Ball's a big one. What else have we got here? Pinwheel. Refrigerator. Okay, let's start to remove some of these from. Flat food list. Not food. Okay, we're going to spend 10 minutes removing foods from this list, or not in foods from this. Let's get another timer. Where is our timer at actually? 21 minutes. Okay, let's spend 10 minutes. Mehmet, I appreciate that. 10 minutes filtering data. So you've never really worked on a proper problem if you haven't filtered data manually, have you? So ball. Manually removing not foods from flat food list. These are ImageNet classes as well. Now, where did I view this from? There we go. Make sure we open that. Not food list. So we got ball, squash is a food, puppy. Puppies aren't food. Are puppies food? In some countries, maybe. Not in my world. Alligator. If they're on the borderline, they can stay as food. Periwinkle. What is a periwinkle? It's a flower. Look at this. I search for a periwinkle and I get ads for dresses. Hey, how are you, Mehmet? We're creating an app called Food Not Food. So you can see the GitHub here, and that'll have the link to the Notion. But essentially, we want to build an image classifier to take a photo of something that's food, not food. Right now, we're building a data set, filtering ImageNet for photos that are food and aren't food. Cockle. If things I don't know, is dog food? Let's put dog in here. I'm building this from my perspective. Game. Rat. Okay, this is good. Most of these are food. Groper, runner, yellowtail, dolphin fish, yellowtail, croaker, mullet, mackerel, ball. Okay, ball's going to be filtered. What's a bar? Blade. Is blade? Blade could be a cut of meat, but we're going to remove blade. Crepe, cross, delicatessen, duck. Game's going garden. Garden's not a food. Hand. Hand and head can be removed. Hey, prison's learning. Jacket, not a food. Oh, I believe we have some food here.
Speaking of food.
Wow. Thank you so much. Wow. Georgia just made me some food. Because we're about 2 hours into this stream. This is going to be the ultimate test. Is I'm going to take a photo of this now. And will the app, if we're building food, not food. So let me show you what the amazing Georgia has just made. We're going to filter some images in a second. But look at this. Look at this deliciousness. So this is our test for the app. Will the app classify this as food or not food? Thank you, Georgia.
Okay.
So we're going to stop for Q&A in a second while I eat this food, because I'm not going to be coding while eating food. So we've got a test case now. Jacket, joint, junk, key. We want these. Key. We have an image now to test out. Why not Twitch today? Because we're celebrating 100K subscribers. That food looks delicious, doesn't it? I'm excited to eat it. Oven, pin. Pinwheel. Now a plate is not food either. We're going to be here for 10 hours, team, so we need to make sure that we're taking stock of what's going on. Plate, not food. Pot, not food. Powder, rack, refrigerator. Saddle, shank. Spoon isn't food. Spring, steamer, stick. Temple. We're going to eat this food in a second. Tongue. Is tongue food? Tongue's food in some places. Truck, turban, wedge. Wedges might be potato wedges. We're creating a data set. Orange, ring. Cornmeal, breakfast, meal, picnic, dinner, tea, stew, caramel, sweet, candy, dumpling, pudding, pastry, donut, jelly, marmalade, bread, challah, flatbread, pizza, toast. This is good. This is really good. Once we remove these, pretzel, sandwich, hot dog, we're going to have a pretty good data set here. Broccoli, squash, cauliflower. Split pea, soy, cardone. Okay. This is working amazing. What is his Twitch channel name? Mr. D. Burke, you're right. Coursera, oh, thank you so much. Hey, Coursera, congrats on 100K subscribers. Thank you so much. I appreciate that. I need to take a photo of that. I got started learning data science on Coursera, and now we're here. By the way, people, if you want a special deal on Coursera, don't forget to go to mrdburke.com/100k subs. Read the T's and C's there so you don't get charged more than you want, but we have some goodies. 50% off the first month free of Coursera's Google Data Analytics, and 52% off my book, Charlie Walks. But let's go back to filtering data. And Siobhan says, please let Georgia know that Stream thinks food looks delicious. The Stream thinks food looks delicious, Georgia. Thank you. I agree. Okay, we're almost through this list. Someone finished Udacity Deep Learning Nanodegree. Congratulations. Massive effort, my friend. Okay, this is beautiful, team. Look at this. We have, these are starting to be mostly all just food. We're preparing the data set. The modeling code and exploration will come soon. Fennel, ginger, mustard, tobacco, egg. These are all foods. This is great. Parmesan, honey, molasses, batter, chili, lasagna, oatmeal. You got to remember though, this is going to be inspired by ImageNet datasets, so wherever that came from. Cup, tea. Well, cup is not food. Cup. That'll be a tough one to do. Honeycomb, iceberg, mountain, ocean, rainbow, star. Star, rock, shell. These two aren't food either. Once the timer goes off, we're going to eat and we're going to do Q&A. So if you have any questions you'd like me to answer while eating, I'm not going to code while I eat. I don't eat while I use a computer, but I will eat while I talk to you. Runner. What's a runner? I don't know. Let's remove that. And pilot. Pilot is not a food. Don't eat your pilots. If you're in an airplane, don't eat your pilot. You heard that here first. Unless you can fly a plane. This is good. We're nearly through. This list is about 1,000 long. And oh, look at that. It's food time. We've got too many timers going on here. It's going to be food time and then it's time to move again, which is beautiful. So, and we're going to stand back up because we're here for 10 hours. How long have we been going for? About 2? Just over 2 hours. We're going to get to the end of this 1,000 list. Ash. Ash is not food. We're making a data set to build food, not food. Chickpea, soy. Okay, I'm pretty confident that the rest of these are going to be all food. Have you worked on a machine learning project if you haven't manually sorted a massive data set? Rings going. Belly. Oh, it could be pork belly. Sand. Sand is not food. Done. Okay, so that's next. Let's write this down. So code next. Answer QA while eating. So this is the test case food. The beautiful Georgia has made me some food. That's gonna be the test image for the application, food, not food. Then filter out non-food items from data frame, manually sorted, and then download ImageNet food and non-food classes, class images, and then make data set of food and not food. Okay, we're on. We're going to take a break. We're not going to code for the next however long it takes me to eat this food. But look at this. This is some delicious food that Georgia has just made for me. So if you have any questions, leave them in the chat, and I'm going to be answering questions for the next 10 minutes or so while I eat this. Oh man, can we please do these streams often? Yes, I'm looking to stream far more in the future. I'm going to keep building the app that I'm working on, which is called Nutrify. Wow, look at this. Omelette, mushroom, In my country, do timers go backwards? In Australia, everything goes backwards, man. We barely even use words to communicate. Like in Australia, we say, like, yeah, nah, yeah, is a valid reply in Australia. Who's Georgia? Georgia's my girlfriend. What would you say about reinforcement learning? I don't know enough about reinforcement learning. I think it's very valuable. DeepMind and OpenAI are doing a lot of cool things. But I don't know enough. I'm not skilled enough in reinforcement learning to comment. And I haven't yet seen like a real big use case. There was one in the State of AI report saying that reinforcement learning was used for, was used for, how do you say, restocking shelves at like a supermarket. Hey, Daniel. Good name, first of all. But you passed the TensorFlow certificate last week and just want to say thanks for the motivation. Oh, man, that's so cool. Congratulations, legend. Mehmet says, am I from Australia? Yes, I live in Brisbane, Australia. Kevin says, where can I get that shirt? I should have a store and sell this shirt. Let's find out the brand of this shirt. Hold on. The brand of the shirt. Was there a girlfriend reveal? Georgia has been on the stream a couple of times. She's bought me some tea and some food, but there was no like GF reveal. No. The brand of the shirt is Otway. Otway clothing. They look like they make some good stuff. Look at these guys. This is Australia. You can buy some brown overalls. You can buy a jacket. But yeah, Otway is the brand of shirt. Okay, we're going to finish this food. I never eat in a rush, but we do have to get back to coding. Let me get the chat back up. We're just taking a short break to eat. Can I show you my Notion setup? I can, but I think organizing, like it should be, if you're going to organize your files in something like Notion, you should create it yourself. That way you know where to look for things. This is delicious, Georgia. Thank you. Dan, hi, how are you? We're taking a little break to eat some delicious food before we get back into the stream. How many calories do I eat per day? I would say somewhere between 2,500 and 3,000. I haven't measured in a couple of years though. Amar, making you feel hungry? Well, you should have known that when you tune into a food, not food app building stream. No, I'm kidding. How long we got left? Whoa, 7.5 hours left. But it doesn't really matter. We'll just go to when we need to go. 10 hours, easy money. Have I done anything with knowledge graphs before? I haven't actually. I don't think I have. Maybe I have, like, without knowing it, but not knowledge graphs. I haven't used a knowledge graph before. But graph neural networks are starting to become a real thing. So possibly I will do that then. I haven't had a need for it yet. I probably will once I get deeper into building Nutrify. Hey, Ashik's eating breakfast too. Good on you, legend. Siobhan says, congratulations on your success so far. Did you believe you would be here today? You know what? Secretly, yes, but like, you can't really predict where you're going to be. So, like, I really don't feel any different to how I did 3 years ago. I'm just sort of, now there's just the numbers are larger. Does that make sense? Like, I'm still curious and I like creating and I like learning things, but it's just, everything else has grown around that. So I developed the habit of continually learning, continually creating, and then somehow the internet has worked its magic and we're here today and people are watching all over the world, and I thank you a lot for that. And so I always treat it as like a circle. It's like I create things to put it out there. People respond to that. That motivates me to keep creating. And it just goes on and on and on and on. But there's never really been a, hey, you know what? I really want to get to 100K YouTube subscribers. Oh, you probably know that I don't really care about the number. That's not to say that I don't care about the people who are subscribed. Is that the number on the page there'll always be a higher number on the page. So it's now I'm at 100K. It's like, well, why don't I get to 200? Well, for me, that doesn't really motivate me. It does for some people. For me, it's just like, am I creating the things I would like to enjoy? Am I having fun every day? That's my main criteria. And I feel like if I'm having fun, the people on the other end of things will be having fun. So who knows? My only talent is getting very curious about something and then following it for long periods of time. Hellhound started the TensorFlow course on Udemy a couple of months ago, but had to make a pause due to school. Coming back next week, regards from Mexico. Oh, all the best, my friend. Enjoy the course. It's a pretty big one. But tuning in Mexico, that's amazing. Ariel, I just want to ask, I'm a software engineering student, so all my programming knowledge and focus all this time is on data structures and algorithms and OOP. How useful are they in ML? Well, 100% that's useful. So, like, that's what machine learning is. It's basically just writing algorithms to manipulate, to find patterns in different data structures. Look at that. It's a time again. It is time to dance. It is time to move. Oh my gosh. Which tab is my timer on? There we go. Okay, we've got to stand up again because otherwise we'll be sitting down for too long. But that's what machine learning is. It's like programming just with data. So, have I read about deep learning transformers? Yes, I have. I'm going to make more materials on those in the future, so stay tuned. Transformers are seeming to be one of the universal architectures. However, there was another paper the other day that started to say like, hey, is it the transformer architecture itself providing the benefits, or is it how you pre-process the data? Am I working as a company as a machine learning, deep learning engineer? So I work for myself as a machine learning engineer. My main title at the moment is machine learning instructor, but I'm working on a project called Nutrify at the moment, which is going to be my return back to being a machine learning engineer. Well, I'm a machine learning engineer now. Okay. Food is done. I'll be back. I'm going to take this to the kitchen, and then we come back and coding, all right? Okay, we're coming back up. Now, I just ate, so not gonna move. We'll do double movement next hour. Okay, we're going back to code. Thank you for joining me with the food. Let's get this over here. Let's get the chat back to where we need to go. Chat. Hello from Egypt, thank you. If you've just finished the hands-on machine learning book, what would you suggest to read next? Any of Andrei Burkov's books. So Andrei Burkov, 100-page ML book. I like these books, 100-page machine learning or Andrei Burkov, machine learning engineering. Those are both two good books. You can read them both online for free. But now, we are back to coding. So I'm going to put a timestamp here, for when I transcribe this video. The timestamp will show that I'm back into coding from the break. So timestamp here. Okay, let's go. We need to now remove, we created this manual list of not food list. So if you're wondering what we're doing, we are building a data set of not food and food items. And as we learned from Abraham loss function, it's important when you're starting a machine learning project to spend a lot of time preparing the data set. So that's what we're doing. What happened to your Apple Magic Pad? It's still here. It's still here. I like to use both now. I found out I'm back to the mouse world. So we can get rid of this, not food list. Wonderful. And we only want the top 5. So we've answered the QA while eating. Well done. So the next eating break's going to be in about 3 hours or so. So like 1 or 1:30. By then we'll be halfway through the stream. Who reckons we can get this full app built by then? Our limiting factor is going to be how long it takes to download food. Download food images. So now let's recreate our actual non-food data frame again. And df food equals not in is in I'm going to clean this up later, but it'll work. Remove even more not food items. Does that make sense? Not in not food list. So how many does that remove? We got 941. Let's just put this here. 941, good time. If you ever noticed that Apple, look on, this is going to blow your mind. I'm going to blow your mind for a second. I used to work for Apple, and this is the Apple time. Every product on Apple's website demos with 941. Let's go Apple iOS 15. Every demo photo from Apple has 941 in there. Ready? 941, 941, 941, 941. You can't unsee this now. 941, 941, 941. Does this even have 941 on here? On the non-Apple phone? Yes, it does. 941. 941, 941. So fun fact about that. Jack Arnold, thank you so much. Oh, I remember you from the beginning, my friend. Thank you. Good to see you here. I appreciate it. Alex, yes. Data pre-processing is very hacky, but that's all right. We're gonna make it. We're all gonna make it. DF food, remove. Oh my goodness. No, we need DF food. Not in. Boolean series key will be re-indexed to match. Okay, so now let's have a look at DF food. Dot. Okay, so we removed about another 100 classes. That's good enough for me. So now we have DF non-food and DF. So let's get list of non-food and food class keys. Let's go, this was made by going through by my criteria equals, I asked myself, is this a food? Okay. Still building the data set, almost 3 hours in, but that's okay. I wanted to make this as real as possible. So DF food, ImageNet, food, class IDs equals DF food. What are the column names? Let's cancel this. Get rid of that. Sin ID. Okay, that's what we want. DF food sin ID dot to list. We actually could. We want this as a dictionary. Yeah, that's a better option. Is it class name? What does that look like? Sin ID. let's go. This is what we can do. Turn it into a list and then combine them to list, and then we want there we go. Okay, now this is our food. Can we do ordered, Dick? So now let's do the same, but for non-food. There we go. Okay, we're on. So now we have the non-food. We finally have split ImageNet. 28,000 non-food items, or sorry, 21,000 thereabouts. And we have 862 food classes. So, who wants to now download some data? Kevin, I really appreciate it, brother. Appreciate keeping it real. So, yes. Yeah, you're right. Alex, the 941 number is the iPhone was revealed at 941. So now we've got a dictionary of classes. We've got to figure out now how to download them. So let's open up a terminal. We'll get the downloader script. So have I started this? We need a list. So let's go to Notion. Updated list of ImageNet food and non-food items to include ImageNet keys from hey, did that have GitHub in there? Notion now embeds GitHubs. That's cool. Okay. So we want this script. Are we running? We're not running on here anymore. We can close that terminal. ls make dir ImageNet downloader. Let's go. I need to give some claps to this. Martins Frolovs. Good morning, Renuga. Hello, hello. Thank you for tuning in. Good to see you here. Images per class. Okay, so a lot of images in ImageNet have over 1,000 images per class. This is beautiful. What a great blog post. %80 of the Flickr URLs are successful. Yeah, so it's only going to use Flickr URLs. That's all right. Let's go here. The data downloader only uses Flickr URLs less than total ImageNet images. Because ImageNet images are downloaded with different URLs. However, Flickr URLs are most reliable. I'm very excited to watch GTC next week. I haven't got one of the new MacBooks, but probably later. Yannick, thank you so much for joining in. It's late in France. It's going to be recorded. Yes, it'll live on the channel after it's done. May the force be with me. Thank you so much. I'll see you next time. .2 seconds per image. Wonderful. How much space do I have on this machine? Okay, let's see. Let's go to here. Let's clone the repo. I actually want to move this folder now. What's happened there? Ah, I see. So we actually just want to move We're just cleaning up the repo here. Okay. What's in the requirements.txt here? So we want, what requirements do we need? Oh, it's all written in Python 3. That's beautiful. Hey Noah, we're working on creating an app called Food Not Food. So we want to build a full stack machine learning app to allow you to classify whether a photo is of a photo of food or a photo of not food. And the notes that I'm taking are available in Notion. And the code, let me update the code. So it's going to be full. It's going to be deployed by the end of the stream. So we want, let's get out of some extra tabs. How do we use this? Python downloader.py. Let's just try, what's data root? Okay, beautiful. So we need to create a folder of images. Now let's just download 100 random images or so into there. Get rid of this shopping website. Python. Downloader.py. We're going to do number of classes. We'll just get 5 random classes. 5, and we'll also get 10 images per class. Here we go, scraping images. Look at that, light brown held escapement diameter. Yes, look at this team. Woo-hoo-hoo. There we go. Okay, so downloaded some images. So ran a test command to download images from with so this was bash. Now let's have a look at these images, hey? Oh, wrong machine. I'm running this remotely. So there we go. Look at this. We've got some images now. This is diameter. And then the class is wonderful. Look at this. We have images now. Ah! That's from Herald. What does this mean? I have no idea. Light brown. Beautiful eyes. Okay, so now we need to get rid of all of these. Look, this is funny for ImageNet. It's like, why? How is this North Carolinian? Anyway, okay, so we have data downloaded. Greetings from Turkey. Hello, hello, hello. Greetings from Brisbane, Australia. So we have some images, officially have some images. Let's, oh, I didn't mean to close that, but that's all right. We can get that back. So now we want, how do we get a list of, see if we have here, ImageNet food class IDs and date. Oh goodness. We need to run this all. Is it going to error? Wow, it didn't error. There we go. Okay, so we need to figure out how we can pass. Who knows how to pass a list to a script like this, right? Or can we just run this in Jupyter? Python, how to pass list to command line argument. Who knows how to do this? Hey, you're from Adelaide. Nice. Hey, they look like they're downloading from ImageNet too. Okay, so we can look like we can do... Quibi, hello, hello. So we need to pass a list. We want this. We want this as keys. We want to pass this list to our command line argument. This is the keys that we want. What is this? Let's get out of this. And let's get out of this. PyTorch. And let's get out of this. We'll put that up there. All right, so this is what we want to do. We want to somehow pass this giant list to this command. Can you have an autograph? Sure thing. We'll download 500 images from each of the selected class. So, can you pass a list? Can I just run this from in here? Python, hello from Seattle, WA in the USA. Hey, thank you for the great content and training courses. It helped me transition from software engineer to data scientist. Wow, that's amazing. With a large software company. Congratulations, my friend. I really appreciate that. Oh, and don't forget, people, actually, I'm going to say that at the next hour, is the surprises. Don't forget the surprises. If people want some surprises, go and check out this link. 100K subs, giving away free months and discounts and whatnot everywhere. So this should work, I reckon. Let's go here. We want data root is going to be, let's try this. Try to download images. Python. Now we want data root to be test images. And then we can go enter. We want number of classes to be 5. And we want images per class to be 10. Test images does not, oh, because it's right here. There we go. Deciduous plant, soil pipe, Swedish meatball, windfall, buckeye. There we go. Okay, so that's downloading images there. Now, wonderful. Let's try test list. Okay, test list images. don't want to modify the original file. Empty string. Hey, there we go. Is it really live? Yes, I'm live here. I'm right here. Curtie, how are you? Are there any content creators that I look up on YouTube? Doesn't have to be ML. I watch RuneScape videos. Curtie, I'm live. I'm live. I'm right here. It's not pre-recorded, my friend. Ask me to hold up a number on my hand and I will show you that I am live. Is this going to work? No. Okay, so we need a way to pass in a Python list. Big fan, thank you so much. So let's go, how to pass Python list to command line. Who knows how to do this? My goodness, the ads on this website. Oh, any creators that I look up to on YouTube. Is the stream going all right? I just got like a bit of a lag spike. Three blue, one brown, of course. That's what I need to do. I need to use where's the downloader script? This is beautiful. So we have a default type equals list. Can you pass Pass string from file to Python command. Can I just pass in a list? I'd like to do this. Oh, derp. Done, done, done. Look at that. Thank you, Alex. I appreciate it. Someone's saying add a... There we go. Okay, fish on, team. Test images. Wedge. Boom, look at that. Okay. Thank you. I flag. Should I? This is what I'd like to do. I'd like to export these to a class, just a file, a text file, and then can you use what's inside a text file in here? Does that make sense? Python, use contents. This is not very Pythonic, but we can try it. So let's create the big one that we want. There we go. There we go. Okay, now let's go food class. There we go. Beautiful. So these are the food classes that we want to download. Does this make sense? I want to put this into a file, and then with this command, with this command, I'd like it to download the images or read it. Is there a way to do that? If I pass in a text file here, does that make sense? So this is the command I'd like to do. All right, I'd like to do this, but then I'd like to pass in this food class ID string .txt. Can you do that? Someone let me know if we can do that. Otherwise, we're just going to have to who's ready to start downloading some images? Let's just start downloading. Let's just throw it to the wind and we can fix this up later. Daniel, tutorial was uploaded on official TensorFlow website, right? Anyone can forward me that link, please. What do you mean the tutorial on official TensorFlow website? My tutorial or a tutorial on this? How many images per class should we do? Let's just start downloading some images, hey? One pot dish says my tutorial was uploaded to an official TensorFlow website. Was it? Victor, what's going on? If you find the link for that one pot dish, I'd love to have a look at that. Let's create images, make the food images. Oh, let's make the data. There we go. And then we'll get non-food images in data as well. Okay, who's ready to download this? How many images per class should we get? If we have food, we want to download, or actually let's get non-food images from ImageNet first. Non-food. We have 20,000 classes here. So non-food class ID list. And so if we download, if there's 20,000 classes, we want, let's get at least 10 images, because that's going to be, if there is 10 images, that is, it's going to be 200,000 images. Data, non-food images. You ready to try this? Non-food images, use class list. We need string. I don't know if my TensorFlow tutorial's on TensorFlow's website, but if you just search Daniel Burke TensorFlow, you'll find all my TensorFlow stuff. Okay, let's download this. Who's ready to download images? In 3, 2, well, I need to hold my fingers up correctly. 3, 2, 1. Let's download some images. Oh, what did we miss? Argument list too long. Damn it. Yeah, that string is 208,000 characters long. What's the maximum length? Okay, I got this. I got an idea. We're just going to download random classes, and then we're going to filter it on the back end. Yes, that's a great idea. So let's just download random images, data. We're going to make dir, and then we can filter them. Oh, this is genius. Make dir, data, images, ImageNet, images. So we're going to download random classes. Let's do that. Number of classes, let's do 1,000. And the number of images, let's just execute this in the terminal. We can just, all the filtering we've done, we can filter it on the back end. So number of images per class, 100. And number of classes, well, let's go 50. So Python. We're going to go downloader.py. We're going to store the images in data ImageNet images. Oh, it needs to be data ImageNet images. Data root is number of classes. Let's get 1,000 or 500. 500 classes should be enough. Oh, let's go the whole hog. Why not? 500. 1,000 classes. And then images per class. 100. So that's going to be 100,000 images potentially downloaded. Should we do more classes or more images? Let's do 50. There we go. Ready? 3, 2, 1. Let's start downloading data. Boom. Okay. Now, this is going to download. It's going to take a while, of course. So now ImageNet images is filling up. So we can filter this on the back end. Heal. Okay, beautiful. This is beautiful. Scraping stats. Flicker. 57%. 65% success rate. So we're downloading images. How can I concentrate 10 hours straight? Who knows? We're going to figure out. I'm going to go get a drink of water. But we're now downloading images. So we're going to filter these images on the back end. Oh, would you look at that? It is time to do some push-ups and dance around. Started downloading images from ImageNet. Going to filter these on the back end into food images and non-food images. Command used. Downloading random images from, or 50 random images. 50 random images from 1,000 random classes. Then filter 1,000 random classes and images into food, not food. Beautiful. So this is downloading. It is now time. We've got a 75% success rate from downloading images from Flickr. So now let's do some push-ups. And what are the rules? Let's come back to Notion. "10 push-ups, 10 squats, 10 kicks, 10 punches." But this time we have to do double because we missed the last hour. "20 push-ups. Now we've got 20 squats. Let's move this over here. Just a little timestamp. We are downloading images now. Timestamp, downloading images. 20 squats. 1. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Beautiful. 10 kicks. We'll do 10 kicks each leg because we need to do 20 total. 1. 8. We could do a MoveNet classifier for if I'm doing kicks or not, or punches. 1. 2. Now we've got 20 punches. Whew. Okay, it's water time for me. We are downloading thousands of images. We could end up with close to 50,000 images here. So we're collecting a data set. That's almost ticked off. Then we have to model the data set, build the application and deploy. Oh, please. Thank you. Oh, well, would you look at that? Get the water delivered by a little fairy. Oh, thank you, Georgia. Okay. We've done surprises. Check out the free stuff. The free/discounted stuff. Don't forget, back online. Oh, please don't tell me the download script has sent us offline. Are we back? If we're back, let me know in the chat. Should we start building a model? Am I back? I'm back. It got kicked off for a bit. Thank you so much for people saying that I'm back, because I'm back. We need to set another hour timer. Okay, while this is downloading images, let's start to build a model, hey? And we should also, we need images of food as well, so we should get the Food 101 dataset. All good again, thank you so much. So food images are downloading. My shirt's coming undone. It's not that kind of stream. This isn't Twitch. Not an e-girl. Okay. So now we're downloading images. We should start to get Food 101 images, or we could start to build a computer vision model. Because once we get the data set is the biggest part. Once we get the data set, the models are ready to go. Do I have TensorFlow? Let's start looking into this. Model building. TensorFlow, yes. TensorFlow config. We have a GPU available. That is what's up, but we need to silence the TensorFlow warnings. There we go. We got our NVIDIA Titan RTX. Compute capability is 7.5. Do we have Gradio? We don't have Gradio. That's okay. How many images are we having? Oh, this is what's up, team. Bleeding Heart. Bobcat. Okay, let's close that because that's going to use up a lot of memory. But we need a data set before this. Let's turn off TensorFlow warnings. Daniel, do I watch cricket? Yes, I watch cricket. I love cricket. Turn off TensorFlow warnings. There we go. Turned off the TensorFlow. Do we have TF Lite Model Maker? We do have TF Lite Model Maker. Beautiful. So because we want to deploy this model, we need to build a relatively small model. Can we build the infrastructure for what we want to build and then just run the code once it gets in? We are building... No, we're just going to leave the images in the folder that they're in. We're just going to load it off that with the TF load images. TensorFlow load images. We're just going to use something similar to this. No. TensorFlow Keras image dataset from directory. This is what we're going to use. Main directory. And then we want to look up how to convert TensorFlow convert saved model to TF Lite model. Here we go. Okay, let's look into how we convert. So we've got data downloading over here. We'll keep that running. TensorFlow Keras. We can save it to a saved model, put it into a TensorFlow Lite converter, and get it out. Wow, you can just do it like that. Convert the model. How easy is that to convert to TensorFlow Lite? Okay. Well, let's start building a model, a sample one. We need to load the datas. We need to load the datas. Let's load the datas, man. I want to move this into here. Move. I don't want that. I want TensorFlow. Okay. So we're going to keep downloading images. Looks like we've got about 7,000 plus images right now. Let's get rid of the warnings. There we go. Because our model is going to be binary classification, we want Let's just make a classifier for aircraft or anvil. Data, let's create a small data set. How many photos of aircraft do we have? Aircraft, anvil. Clear. LS. Let's go move. Copy. No, make dir. Model test images. Copy. ImageNet images slash. When I copy recursive. ImageNet images. Aircraft or anvil? Aircraft to model test images. Cannot copy. Ah. So the files are a little bit too deep, but that's okay. Do I know if there's a good method to convert PyTorch model to TF? Yeah, you can use ONNX. Let's do aircraft versus anvil. There we go. Clear. If you want to convert PyTorch to TensorFlow or TensorFlow Lite, look up PyTorch ONNX to TF Lite or something like that. There you go. This seems like a good guide. That's how to convert PyTorch to TensorFlow Lite. So now we've got a lot more images. Let's start to build a model, hey? Everyone likes building models. So ls data. So we have images of aircraft and anvil. So it's like OS, walk, data, import OS. What is it for files? No, for dir. We need to make a get ignore. Let's add to get ignore. Image folders. Clear. So now we're going to build a model. Now we have to explore our data files. And this is a timestamp for model building. I'm going to leave a timestamp for model building. That way, when I transcribe this later, we will have timestamps for model building. Now, we want to find, let's go print files. Wonderful. That's how many files that we have. Hey, why is that not in OS lister? Data. Okay. Okay, good. Now we want to is there a way to, does this make test size? That was loud. Let's move some random files into train and test. So now we need to create train test. We want aircraft. What's the best way to do this? We want to make a directory in model test images, in data model test images, and we're going to call this train, and we're also going to make another one, data model test images test. Okay, and now we need to make splits of images. So we want aircraft and airplane in here, but we want random indexes. So let's go import random. But there's not the same amount of images in each one, is there? So let's get a list of images. We'll do this the hacky way, and then we'll do this the real way. Aircraft images. Hey Shoba, what's going on? Will you do data monitoring in this tutorial? Depends what data monitoring you're talking about. Shoba, we are building a full stack machine application called Food Not Food from scratch. That means we're collecting a data set, and we are going to be modeling it and then deploying the model later on. So aircraft images equals, okay, so we want to get random indexes from this and then move the rest that aren't in there. How many images do we have? James Scott, what's going on, legend? 53, that's all right. So we can go train split equals 0.8 times length aircraft images. 42, okay, so we have 11 test images, that's all right. Train split. We want NumPy. Huh? Wonderful. Six hours to go. I feel amazing. We still haven't even got into the model building stage. But what we're seeing here now is that building a data set does take the longest part. So when you want to work on a custom project, you need to build a data set. Now here's what we want to do. We want to get random indexes of certain number from list of images. So we want a list of images. What's the random choice in Python? Python random select K. Sample, that's what we want. Python random seed. Okay, let's go import random. I think we don't need NumPy, I don't think. Random sample from aircraft images. I only want 10. Okay, and then if we do random seed, beautiful. But then we want yeah, that's what we can do. Randomly select let's get the train split up here. Train split. Random sample, train split, train image, and then test image list equals aircraft we want to get the ones that are not in. Set. No, I want the difference. There we go. And then we should have length. So we've got a fair few images now. This is good. Wonderful. Okay, so now we want def create train test list target dir. We're going to functionize this. So now we want we're still downloading images, people. But now we need to pre-process our data into training and test sets. Wonderful. There we go. Okay. We're on. Random sample. We've got a list, a beautiful list. Now we need a list of DIRs. That'd be much better, wouldn't it? So target DIRs equals data so then we can get that list. Now we need to create a function to move images. So we want to copy all of the images from let's make another dir. Hey Dewar, what's going on? Split. Well done. Okay. Now we can get rid of these. Print image dir, we want beautiful. Okay, but we actually want the full file path there. There we go, team. We've got lists of random images of train and test. We're on a roll here. We're making training and test sets here. There's probably an easier way to do this, but I'm hacking around, having fun. There we go. We've got a way to move images into train and test. So let's now do the same. So I'm just moving. Lakshman, thank you for 100,000 subscribers. Congratulations. Wow, I can barely talk. Congrats on 100K. What are you using to identify food, not food? I'm going to use a ImageNet model, probably. Image compression web app is getting server timeout. I'm not very experienced with that. Is it possible to do ML work on the client side instead of server side? Yes, it is. That's what I'm going to be doing today with TensorFlow JS. So I'd look into that, TensorFlow JS or TensorFlow Lite. So let's now copy. Is it copy to? Python SHU to copy. Okay, copy to. So we've got to make a target directory. Okay, I need another helper function here. Congratulations. Thank you so much. Hi, Vineet. How are you? We're still downloading lots of images here. 74% success rate. This is beautiful. Be back.
Use the right. Yeah?
Right touch.
Yeah.
Okay, I know what to do now. There we go. Oh no, we need the reverse. We need train test. Derp. Oh. We got some more movement to do. Wham says hi. Hi, Lex. What's going on? Tell Wham I said hi too. So we need to actually, I need to fix this up. So we're going to do some movement in a second, but I'm going to finish this code. We want make target directory. No, we don't want that. So we don't care about that. Target dir is going to be so now we should have aircraft, anvil, yes. Aircraft, anvil, yes, we're on. Okay, we've got a way to make splits. Do the twist. Now let's copy all of them. Beautiful. Okay, now we can build a model, but we need to move first. We have a lot of images downloading right now. Look at all that. Isn't that beautiful? Nearly 1,000 classes downloading. Okay, next is make model datasets from train test folders. And then next is build model on train test datasets. And then evaluate model, convert model to TF Lite for deployment. Okay, we're on. We've got a data set. Vinette, yeah, I'm not doing much talking at the moment because we've got to write some code. That's what this stream is about. We're doing a machine learning coding stream. And the way we're going to check if the app works is in a few hours. We're nearly halfway. This is very exciting. In a few hours, we're going to check if the website that we build works on an iPhone, or you can visit it. That's how we'll know we win. Okay, time to move. Let's bring the desk up, or actually, I'll put it down. We have, the rules are, let's make a list of hours. How many hours have we done? We're nearly at to 5. Let's go here. Hours. To do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've done 4 hours so far. We're nearly at 5 actually. On my clock it says 5. How long does the stream say we've been going for? Let me know in the chat. But we have 10 push-ups, 10 squats, 10 punches, 10 kicks. Now we have squats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 kicks. Let's bring this up. 5 each leg. Move this chair so I don't belt myself. Ten punches. 1, 2, 3, 6, 7, 8, 10. Now 10 star jumps for fun. I'm going to put a timestamp in here. A timestamp for train and test sets made for a test data set. Timestamp. And now 10 seconds of dancing. 4 hours 43. So John, I am making a website called Food Not Food, which is going to use a machine learning model to predict whether an image is of food or not of food. You can see all the code here, and the Notion is going to track all the nodes. Now, I'm going to get some water. Don't forget, there is the live stream celebration. If you want some good deals, hello window man, what's going on? You can get 50% off the first month of access to all Zero to Mastery Academy. First month free off Coursera's Google Data Analytics Professional Certificate. So Coursera giving us 100 free months for this. So thank you, Coursera. And my book is 52% off. So it's $432. So go check that out. Read the T's and C's, because if you don't unsubscribe, you'll be charged for the second month. I'm going to get a drink. We're downloading about 50,000 images right now. So the next thing is we want to make model. We're going to build a model. This is exciting. Okay, I need to clean up some of this stuff here. I'll be back in a minute. Be back.
Yeah, and then 400 words, that's all. And a heap of references and join things together.
Okay, let's set another timer. Now we need to build a model. Okay, so we need to load the data. Let's do that. We're still downloading lots of images. Load data. Have we got TensorFlow? Did you notice that we spent the first 4.5 hours crafting a data set? That's a big note in machine learning, right? If you want to build a custom project, you need to create a custom data set. And that's what I wanted to do with this project is rather than just start off and build a model straight away, I wanted to have nothing ready and then just start building it from scratch. So let's do that. Import TensorFlow as TF. We're going to figure out how to load some data. I think it's train data or train folder. Trained can be model. We're building, this is on a test images, by the way. Split. This is a test model. We're going to build the real model once all the images are downloading. You see this down here? We've got our deep learning PC, which is downstairs from here, running very hard, trying to download lots of images from the internet. Hot dog, not hot dog. Ashik, we're about to start modeling. Good timing. We've got a test data set up over here, not the official data set because we're still downloading images. If you want to know what we're building, all the code's on GitHub. And we're up to modeling now. We're downloading thousands of images. So let's start building a model. Look how many images we have now. Look at all these classes. How cool is that? But we're going to filter those in a second. So we're building a binary classification model first. I'm going to go load in data. So train data equals tf caras utils image data set. Actually, I think I don't have the latest version of TensorFlow. They only changed that in one of the recent ones. So we're going to go trained. We want, what could be our batch size? Batch size 32. Does this give me a doc string? Labels equals inferred, label mode, color mode, class names, image size. We want 224, 224. And then test data. Found 86 files. Look at all that. That's a bunch of jargon. We want to get rid of the runtime here. I mean, warnings. We got data. So we got 86. This is just a simple model. 86 training images and 23 testing images. So aircraft versus anvil. The first model that we're going to build, first model, timestamp, first model, timestamp, first model. The first model that we're going to build is just aircraft versus anvil, and then we can scale it up to more classes with more data. We'll make sure that the model is running fine with a small amount of data. Build the first model. I'm going to prefetch these data sets as well, so they're nice and fast. Train data equals train data dot prefetch, and we want TF data. We're lucky we got a big dog GPU, because this is going to be... Build the first model. Okay, we can get some model code here. Let's go base model. Let's build an efficient net. TF Keras applications dot efficient net b0. Where's my docstring completion? Docstrings. Hey, we'll just go to the docs. If you're wondering what efficient net b0 is, it's this model. Efficient net b0. This is efficient net, convolutional neural network. There we go. This is what we have. So it's an architecture from 2019, but it's just a bunch of convolutional layers. It's actually mostly purely convolutional layers. So we're going to build the nice and easy one, efficient net b0 to start off with. We can of course scale this up as much as we want as we keep going. But let's look this up in the docs. TensorFlow efficient net b0. So we don't want to include the top because we want to put our own custom layer. The top layer we're removing. So that means when you include the top layer, these efficient net models from TensorFlow, so the pre-trained ones, they're pre-trained on ImageNet already. So we're gonna, instead of it outputting 1,000 classes, because that's what ImageNet has, 1,000 different classes, we want it to output 2 classes. And in our cases, our classes are aircraft and anvil. So we're just gonna change the top, but we also want the weights are going to be from ImageNet. That's what we want. And I think everything else can be, that's about it. Include top equals false. Because then if we go, it's going to download the base model. See, downloads this from Google. Thank you. And then we want to go base model dot trainable. So this, right now it's trainable. We want to turn trainable off. That means we don't want to do any fine tuning. Because if we download this model, it's going to be hundreds of layers. Let's have a look at that. See how many layers that is. So heaps of layers. If we turn trainable to false, make model untrainable, it means all of these base layers are going to come with the patterns that they get downloaded from, and we're not going to adjust them when we train them on our own data. So that means the patterns that this model, the weights that this model has learned from ImageNet, are going to remain the same as when we downloaded it. But, oh, we should use weights and biases. Let's do that. Before we train a model, we're going to use weights and biases to track our experiments. So, make model untrainable. We'll just construct the model first. .trainable, we can set that to false. And then we want to build a functional model. Input equals input layer. It's TF, Kera's layers input. Then the shape is going to be 224, 2243. And then we want X equals base model. Pass it the input. And then we want X is going to be TF, Kera's layers. We want a global average pooling 2D. On the export here. Is that how you do it? Where's the functional API? That's what we need to look up. TensorFlow functional API. I can't remember the syntax. Why not EfficientNet v2? Oh, we could do that. Daniel says hi. Oh, good name. Love from India. Hello, hello. Can you post your GitHub link? The GitHub link is here. 5 more hours to go, team. We're halfway. Woohoo! Is that correct? So we're not including the top layers. So let's have a look at this. What does this mean? Where's the functional API? Is the syntax here correct, Ashik? There, yeah, it's correct. Okay, I forgot the syntax for a bit. I've been writing PyTorch code. TensorFlow is a little bit different. So you still don't understand the meaning of include top. Okay, let's go here. Online whiteboard. Look at all this bullshit ads. Just give me a whiteboard. There we go. Okay, so we have, this is a model and it's got layers here. Okay, this is our baseline model. And when we download it, we get the whole thing, right? But when we set include top, we only get this section. So include top, false, we get rid of that. So we can put our own top on, which means we're gonna have an image here of something, and I know my face is in the way. Hold on, let me move my face over here. Right, this is our input image, okay? That's gonna go through the model, and the model's layers, all of these patterns here, are going to be passed to our own layer. So in the case of the pre-trained model, it was trained on 1,000 different classes, because you can see that here, that's on ImageNet. ImageNet is a data set with millions of images. We're actually downloading a lot of them now, and it has 1,000 classes in there. However, with our problem, we only want 2 classes, which is Anvil or Aircraft. So we have the baseline model here, which is all these layers, poorly drawn. But when we set include top to be false, we remove that top layer, which says 1,000, right, classes. And we only want to put our own layer on the top and say 2. So we still get all the power of the model's, what it's learned and its different weights on different images. But instead of outputting to decide, is this one of 1,000 classes? We're deciding, is this one of 2 classes? Does that make sense? So the same inputs, same baseline here, but now instead of outputting 1,000 options, we're outputting 2 options. So that's what we're building at the moment. And that's a very poorly drawn one, but I've probably got a better illustration on my TensorFlow GitHub. Ashik, do you know where the slides are for the... Ashik, do you mind linking the slides to the... can you link the tutorial where we do, what's it, not fine tuning, feature extraction. Can you link the feature extraction stuff in the chat, please, from the TensorFlow GitHub? Now we're going to do an output layer. Output layer equals TF Keras. Oh, do we need to, could we use EfficientNet v2? Let's compare them. That's what we can use weights and biases for. TF Keras layers dense. We want 2, right? Because this is our top layer. We only want 2 classes. Oh no, we actually want 1. Because we're going to use a sigmoid activation function because we're doing binary close entropy. Construct model. Model 1 equals TF Keras model input layer. Now this is probably going to be busted. Input layer, output layer. Because there's probably an error here. That's right, I haven't even included X there. Build a model. Do we need an activation function for the output here? I don't think so. I can't remember. Now let's have a look at our model. Model 1. What error did we get? Did we get error? Yeah. Inputs to a layer should be tensors. Why is that not working? Inputs to a layer should be tensors. Oh, input layer. Oops. There we go. Okay, now let's have a look at our model. From Keras, tf keras.utils, import plot model. Hey, what's Keras utils? Keras plot model. Pip install py.. Oh, we need to restart this. Will that matter? Yeah, why not? We're going to install weights and biases anyway. Okay, let's start getting weights and biases ready. This is a timestamp for getting weights and biases set up. Pip install restart. That's all right. Let's install this. Pip install py.. Pip install weights and biases, hey? Did I do an uppercase K? That's all right. Oh, I have to install a bunch of different things. I have to install GraphViz. I'll be shocked if this works. I'm going to just YOLO install this. There should be a YOLO install. There we go, installed GraphViz. Let's get weights and biases up and running. Weights and biases, TensorFlow. Clear. Weights and biases, init paramdic. try the collab. Okay, we're going to set up weights and biases to track. Here we go. Weights and biases. And we want hyperparameters defaults config. That's what we can do. Yeah, so they set up a config. This is going to be great. Okay. That way we can compare EfficientNet v0 and EfficientNet 1. Yeah, I had to install a bunch of things for... We're getting weights and biases. Then I need to weights and bias a init. Import WMB. Let's get a lot of code on the screen and make a really fun face so we can get a thumbnail for this video. Thumbnail, like, should we go hacker mode? Like, I need to find a thumbnail for this video. So there we go. It looks like we're doing a lot of coding here. Thumbnail. Okay, so we're going to get weights and biases working so we can compare two different models. But now let's make sure all of this runs. Can we import weights and biases? Yes, we can. Okay, so we want... How did they do that here? Add a few lines to any TensorFlow script. So weights and biases param dictionary. Weights and biases, TensorFlow guide. What's this one saying? Can we use a functional API? We've still got images downloading and we've still got plenty of time. So this is where we're going. Load files from drive. Okay, I'm going to turn my screen off for a second while I log into weights and biases. So just give me a moment. Hey, move this chair so we look professional. Let me log into weights and biases. just authorizing my weights and biases account. Signing in with GitHub. Hello, Aquid. I'm just logging into entering an API key here. Okay, I think I've logged in. Let me just make sure that that key is not there. I'm going to stop this. Project equals okay, live stream modeling. Oh yes, team. We're on. Okay, so we've now got weights and biases up here. Let me just bring you back on. Welcome back. Who was that one person who, do I have any web or mobile development background? No, I'm only machine learning. One person who disliked the video. Well, we don't have that. Surely no one had disliked this video. Okay, weights and biases, where are they using? Next, you import the weights and biases, init. So that's what we want to do, sync TensorBoard. Sync tensor board, yes. Neural net. Hey, this is with TensorFlow 1, dude. Why are you using TensorFlow 1? Weights and biases, sync, tensor board. This is what I want, TensorFlow. Is this just going to automatically log? If this automatically logs, I'm done. Let's find out together, hey? Let's build the model. Plot model. So this is what's happening now. Do we have include shapes? TensorFlow Kera's plot model. Yes, I'm going to be deploying. I'm going to be deploying with TensorFlow Lite, TensorFlow JS. Show shapes, that's what we want. There we go. So this is what happens. We have our images that go into ImageNet. ImageNet outputs a feature vector of size 1280. So that means that our ImageNet model is going to turn every image that we put into it into a feature vector of 1280 size. So one big array of numbers, that's 1280 numbers long. Then we're going to global average pool that to condense it to a single vector, smaller vector, which is this, the output of that. And then we're going to condense that again into another output vector of shape 1. But I feel like we could have another layer in here. But that's all right, we're going to condense it all. We'll see how the model trains first. So let's compile. This will be interesting. Will weights and biases track this? If it does, I'll be interested. I'll be very surprised. Are we still downloading images? We are still downloading images. Compile model, model.compile, loss equals tf kerras. Losses, we want binary cross entropy because we're doing a binary function. Model 1, we need an output activation. That's what we're missing. I thought we were missing something. Sigmoid, did someone miss that? Did someone get that? Activation equals sigmoid. Model.compile, optimizer, we're going to use our faithful atom. TF kerras optimizers dot atom. Learning rate can be the default, and metrics equals loss. No, accuracy. That's all we want. Why is metrics getting angry? Now let's fit the model. History 1 equals model1.fit. We're going to fit on the train data. How many epochs? Let's do 10. Let's do 25 epochs. It's going to go pretty quickly, but we'll use early stopping. Create early stopping callback. Now, what we want to do is make sure, so early stopping means that once our model starts to get worse, it's going to stop. So patience equals 5. If it doesn't improve on metric monitor, I believe it is, monitor equals, if it doesn't improve on the val loss, validation set, oh, we're not going to have a validation set, are we? If it doesn't improve its loss, do we have a validation set? Yeah, we do. We will. We'll validate on the test data. Epochs equals 25, validation data. So our model's going to train on the training data. It's going to validate. So it learns on the training data and then it tests itself on the validation data or the test data. That's why we created a train and test set. So let's go test data. And then we want to go callbacks equals early stopping. Who's ready to fit the first model? Will this, I don't know if this is going to upload to weights and biases. Actually, let's give this a model name. Name equals ImageNet B0 V1. Compile, epochs, let's go 50. Ready? 3, 2, 1, fit. Oh, we get an error. What did we get wrong here? Oh my goodness. Look at this. Input 0 is incompatible with layer ImageNet. Expected shape. What is this? 223? Oh. Who caught that? Of course it was me coding that wrong. We're fitting. Okay, first model. Timestamp. First model. Timestamp. First model. Oh, TensorFlow's output. Look how fast this is going. Done. Okay, our model is performing at 100% accuracy. So that is insane. Model1.evaluate test data. Okay, our model performs at 100% accuracy. Great, we've built a first model. How goes that, team? What What would you do at situations where you're absolutely stuck with 2 to 3 things with the same deadline? So I would, do I need to use, .log for weights and biases? You're right. But there's no clear statement here that tells me how to use a log. How do I turn off these warnings? Please don't give me so many updates, TensorFlow. Look at that. Okay, the GPU is very quick. Okay, 95% accuracy. That's pretty darn good. I'm happy with that. Weights and biases. We've built a test model. How good's that? Let's get TensorBoard logs. If you go to learn-tensorflow.io, it's a book. TensorBoard. Ashik, when I'm stuck for different things, I would just pick one. Focus on one. Create TensorFlow callback. I knew I had one of these. So we're going to copy this. Oh my goodness. Why does it do that every time? So now we're going to import helper functions. We can delete helper functions 1. Are we still downloading data? Oh, the data is finished. We've got food images. We've got images, people. We can start to build a bigger model. So now we're going to do that in a second. We've got to finish. We're going to get weights and biases logging up here. Still nothing here. Callback. dir name, target dir. Experiments equals, let's do create a dictionary. I think this might work. Is that how I do it? See, this is why you write a book, so you can come back and reference your own code. Thank you. Yes, please. Oh, it's snack time. Did the timer go off?
No, when you're ready, my timer went off.
Okay, here we go. This is how we're going to get TensorBoard logs. Okay. Let's see if this works. Okay, how did this go? Did this log into weights and biases? Okay, we got a warning from weights and biases. When using several event logs, so now let's go here. Weights and biases, you need a better guide here. Weights and biases, sync TensorBoard. Don't just tell me to write sync TensorBoard. Sync TensorBoard equals true. Huh? TensorBoard. There we go. Okay, we're on. Okay, now we can try ImageNet v2, but now we need a bigger data set. Okay, we've got more data. This is exciting. Hey, the Cadena, what's going on? I am working on building a machine learning application called Food Not Food, and you can find the GitHub code there. We're building a machine learning model and we're going to deploy it using TensorFlow, and we've downloaded a data set. That's what we've spent the past 5 hours doing, is downloading a data set. So now we've got data, ImageNet images. We need to split our images into food and non-food images. So how about we do that? And I'm sick of getting all these TensorFlow warnings. Let's go logs. Yes. Now I wonder now, because we've got TensorBoard up and running, if we load our data and build another model, will this upload to TensorBoard? Because we've got TensorBoard running here. I wanna make it. I wanna make it with you. Hey, we're on. There we go. Okay, look at this. GPU. Yes. Will this work? If we can't get it to work, I'm just going to now, is this going to be on weights and biases? Okay. I'll be back in a sec. I actually don't know. I'm not using 2.7. I actually don't know why this is not working. Weights and biases, log, TensorBoard, logs. Do I need to write a custom training loop? I'm perplexed. Let's just get into writing. I thought we were going to be able to use weights and biases pretty easily, but it turns out. I thought last time I used it, it was easy as pie. That's what I'm missing, log. Will that work if I just say hey, there we go. What was I missing before? Okay. Okay, we've got some reports here now. Let's now do the same. Oh, we got a timer. You know what that means. We've got 10 push-ups, 10 squats, 10 kicks, 10 punches. We're going to start building a big model because deployment needs to happen. We're going to start building the model after this. 1 sec. Ten squats. Ten kicks. 5 more. 10 punches. Okay, time to build a big model. Next thing we're going to do is just test, well, ImageNet v2 is not big enough. The model's already performing too good on our small data set. So let's now, I think I need to call weights and biases init sync TensorBoard every time I run it. But that's all right. Okay, so now we need to merge a back kick for some variety. We can get back kicks, baby. Okay, so let's move the data. So we need to copy these paths. Now we need to filter out our, I'm going to sit down now. Hello, I'm a very small version of myself and now I'm getting bigger and bigger. Hello, I'm back. Okay. Now let's filter out ImageNet datasets. So we did data exploration before. That can be canned. We need to start training a big model. We've got a small model. Our modeling code works on a binary classification problem, which is what we want because we are doing food, not food, binary classification. And now we have a bajillion images. Let's use them. So timestamp, we're going to filter the ImageNet images now. Timestamp, we're filtering the images from ImageNet. So let's have a look. How many images do we have total? OS walk, image files equals boom, OS for DIRs, subDIRs, files in OS walk. We're going to go into data and then ImageNet images. We need to keep this on track, all right? Do I not have OS? We're keeping this on track. Now, let's have a look how many image files we have. 1,000. There's all the files that we have, but it's really a lot more than that. So we want to append So let's see how many images that we have. We've got a list of lists. Where's our list code? Sublist. I need to bring this back over here. Hey Adam, welcome to the stream. Can we implement PCA using TensorFlow JS? Probably. I'm pretty sure. I've never done it. TensorFlow JS is basically just a JavaScript version of TensorFlow. Find sublist. There we go. We have 50,000 images, people. This is what's up. Let's do that. Let's build a, we've got enough images to build a model. Let's build a model, hey? So let's get the class names. So ImageDirs equals ImageDirs.append. I want to refix this data set so it's just, we've got 50,000 images. Who's ready to build a big model? ls clear, ls, we're in data, we want to move data, ImageNet images, ImageNet images, all to data ImageNet images. There we go. We've got 1,000 different classes. So now we've got image files, and we are also going to get ImageDirs equals hey, why didn't that append subdirs? Huh? So we have ImageDirs. Okay, here's our classes. And now what we need to do is we've got a big food list. So food class. Are the names in there? We've got 1,999 different classes. Why is that? Okay, now let's start filtering some data. Give us the mullet haircut. Heading to sleep, Alex. Thank you so much. Thank you for joining in, Legend. Good night, my friend. This is VS Code, Jupyter, running Jupyter Notebook. So now we need to, here's what we need to do. We need to move images from, we need data. We need to make train and test folders. Okay. This is what we need. We need data, train images, and we need data, test. How long we got left? About 4 hours. Beautiful. That's exactly what we need. Okay, and then this image inside here is going to be food images and non-food images. So let's do that. We need to bring our model building code here. I'm going to make a data splitting notebook. So we want to turn this into team. We're on the up here. We've got data, we've got model code, we've got everything that we need. And then I'm going to clean this all up after the stream. Okay, don't run this cell because that's already run. However, we need to filter. Okay, we want food, df food, class name. Going to call this food list filter. Boom, baby, everybody. Do some dancing, do some romancing. Okay, now we need to split our images from ImageNet images into move food images to food images folder. So let's go here. ImageNet downloaded image folders. So these are the images that we have downloaded. Equals folder name dot lower for folder name. I'm going to lower them all. Lowered. Done. Get list of downloaded ImageNet class folder names. Move food images from ImageNet downloaded folders to data. Gaurav, what's going on, my friend? Gaurav, I use ScreenFlow to record my course videos. And the cool zoom ins are all from editing. Did I set another timer? We forgot to set a timer, team. That's all right. Okay, so let's go. For image folder in ImageNet if image folder in food list filter Oh, we're on here. Figured out how to do it. Dester equals, we're going to OS, we're going to make a dir. I'm going to call it image folder exists, okay, equals true. Then we're going to, no, we're going to make dirs of dester equals OS path dester image folder. Oh, that's what I need to do as well. Follow up tweet saying, actually did this. Post. OS start, we're going to join the image folder. Lister. And then for image to copy in images to copy, copy to I love writing code. We'll get the last one. We'll print this out first. Print. Jesus, how are you? Vishal, thank you so much. I appreciate it, legend. Ah. Boom, 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 boom. Here we go, everybody. Japanese cayenne. Huh? I don't use. Yeah, Amar, you're totally correct. Lowercase is an issue, but now there's this. Rashan, how are you? I don't use a Mac for training. No, I use a GPU. What are we doing today? We're building a full stack machine learning application called Food Not Food. You can find the code on GitHub and the notes on Notion, and all the code will be up there by the end of today. So we're trying to copy some images. What's happening here? Let's step back through the code. I see what's happened. It's just stopping. Need to bring the for loop out. Stream looks like it's coming back online. Let me know if I'm back. Yes, thank you so much. Amar, you're so right. Thank you. I'm back. What do you reckon here, Amar? Oh, did that just restart everything? Oh goodness, I'm gonna have to rerun all of this code. There we go. We got it. Thank you, Amar. I appreciate that. My brother is still coding in Swift, so stay tuned for that. But I don't know enough Swift. Why is this making a new... Food images. Okay, this is what I want to delete. So thank you, Pratik. I appreciate that, legend. Ah, I see. Thank you, Akash. I really appreciate it. Okay, we need to copy all the images to here. I think we've got it now. Why doesn't it make a new folder for Japanese? There we go, team. Food images. Loaded. Locked. Now let's do non-food images. Move food images from ImageNet. Download to. Now time to do the same for the non-food images. There we go, team. Non-food images filling up. Let's get out of that. Data splitting. Okay, we're on. 101 food image dataset created from ImageNet or vice versa. I'm not sure. I think food 101 wasn't created from ImageNet. So now we're going to, oh, it's still copying. Now, we just want to extract we don't care about the classes. The class name is there. So let's write down some pseudocode. Move, extract food images, files, and move to food images. Do the same with test. Okay, I'll be back. I train models on the cloud, and I also train models on my deep learning PC and Google Colab. Thank you. Okay. Background to white. Some people ask for dark mode at the start of the stream. So we switch to light mode for the rest of the stream. Jeez. What do you reckon? Light mode for the rest of the stream, team? Let me know in the chat. Whoa, this is even wigging me out. Okay. So now we have to move. We just need to adjust this a little bit. Let's get all the files in the food images. So food image file paths equals OS for dir OS walk light mode or nah? We're going off light mode. There we go. I got too used to dark mode. .append files. And now let's have a look at, we've literally spent 5 hours manipulating data. That's all right. Python get list of all files There we go. Now, how many food images do we have? 2,800. So we're going to need to pack that up. We're going to need to bump those numbers up a bit for model building. Dan, what are your opinions on the metaverse? No idea. I'm actually sort of not a fan. I prefer the real world. Metaverse to me really doesn't have much appeal. Okay, so now we want to just get copy this. Let's randomly get a train and test split. There we go, train and test, done. Yeah, I'm not a fan of the metaverse or Facebook's version of it. Just put it this way, do you trust Facebook? I know they renamed to Meta, but do you trust Facebook? There we go. Move to train and test. So we're going to take in a path of images, target dir, man. So it's going to loop through this. Let's just rewrite this from scratch because I need some different logic here. Oh, I need to get rid of, I only want to copy. Thank you so much. When is next Machine Learning Monthly coming out? Machine Learning Monthly is on hold for the time being while I make other videos because Machine Learning Monthly is, the videos only last like a week, then they're irrelevant, you know? So I want to make more longer lasting stuff. Image file name. Ah. There we go, team. We got this. This could really be functionized, but we're just hacking along here. We need to get a model training. What are we at? 7 hours. This is beautiful. We're about to get a first big dog model training. Hey. Hey, Soham, what's going on? We're building a model. We're building a full stack machine learning application called Food Not Food. What's the timer going on? If you go to my GitHub, repos, Food Not Food, you can see it there. But we need to get this model built. Why is it taking me so long to split this data? Let's functionize this. Thank you. Thank you, thank you.
That's okay. How's it going?
Thank you. Going excellent. We're on a roll. We're on a roll. Image file name. Oh my goodness. What do we need to do here? Target data equals food images. We're on. Oh, nice. Thank you. Thank you, thank you. There we go. We got images. Why didn't that work? Praise the Lord. Okay, we're on. I know I've said that a lot, but we are actually on here. We can just do the same for... There we go. Okay, now we have two classes. Who's ready to build a big dog model? I'm gonna get a drink of water, I'll be back. We're back. Time is going off. Let's build a big dog model, eh? Don't forget, discounts are live. Go and see the discounts there. Okay, model time. I could do some movement. I got a mouthful of food, but I'm ready to build a model. Listen to that San Pellegrino. This stream is not sponsored by San Pellegrino, but if they would like to, you know where to find me. I'm gonna finish my food first, hold on. We have 50,000 images. Ladies and gentlemen, welcome to the stream. 50,000 downloaded images. Have a go at that. 43,000 training images, 10,000 testing images. We can, of course, upgrade it. The classes are a little bit imbalanced, but that's all right. It's time to build a big dog model. Who's ready? Okay, so this stream contains coding 30% and eating, drinking 70%. 5% Kung Fu, which, speaking of which, we have some push-ups and kicks and punches to do. 10 push-ups. We're at the 7-hour mark. Time to build a big model. I don't know how long this is going to take to train, but we've got a big dog GPU down there, and we're going to push it to the limit. Ten push-ups. What was the other one? 10 squats. 3, 4, 5, 6, 7, 8, 9, 10. We'll get some back kicks going, eh? 1, 2, 3, 4, nearly fell over. 5, 6, left foot. 1, 2, 3, 4, 5, 6. Okay, 10 punches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Energy is back to me. And now we are ready to build a model. Let's go big dog model. We'll start with an ImageNet B0. Or V2, V1, and let's see how long this is going to take. Running, and let's get a NVIDIA SMI and watch. How do you do NVIDIA SMI watch? That's it. Watch. N1 NVIDIA SMI. So this is the GPU. It's currently got all of its memory used. Let's see if we run this big dog model, what's it going to do? Binary cross entropy, early stopping, and we're going to train for some epochs. How many epochs should we train for? Maybe start with 5 to see how long it's going to take. Weights and biases is not defined. Oh, we reset. We reset weights and biases. Who's ready to train? Sync TensorBoard, go. Loading. Create TensorBoard callback is not defined. Classic. We're only really going to get... There we go. We need to... Let's train this model, team. Uploading data. Watching NVIDIA SMI. Oh, look how fast that's going. The GPU is pumping. Oh my gosh. Already had an accuracy of 93%. The Titan, baby. Look at the Titan loading. Okay, we can probably train for a few epochs here, it turns out. Holy crap, now this is fast. This is on 50,000 images. Mind you, the images have been already trained on. Hey, what happened there? Is Weights and Biases logging this? Oh, we're training here. Look at this. We're training live. There we go. Train, step. We've got epoch loss. Compute. How's the compute going? CPU. Where's the GPU utilization? There we go. That's what we want to see. 80% GPU usage. GPU memory allocated. 80%, 99%. Team, we're going good. Very good. Validation. Training. Have a go at that. Now, how do I add some panels here? Yes, this is beautiful. We've got a lot of warnings being pumped out here, but that's okay. 95% accuracy is pretty darn good. Val accuracy is 95%. Hey, Arturo, what's going on? Hey, couple burpees just for fun. We'll do burpees next. 60 minutes. Okay, look at this. This is beautiful. We have GPU is pumping. Actually putting the Titan to use case now. Okay, so we're looking at about 95% accuracy. That's good enough for me. We do have a large class imbalance. We're getting far too many warnings for my liking. Elon Musk. Oh, thank you so much for tuning in. I love what you're doing with Tesla. There we go. Training epoch accuracy is pushing towards 100%. Dogeman, the Dogeman taking everyone to the Mars. Okay, look at the Titan just humming along like no tomorrow. Let's get a model from this, hey? We can save. Save model. convert model to TF Lite. Any resources there? Good morning from India. Hello. You can start this. You need to know TF to build the model. The GitHub is here. Have we done 5 epochs yet? How's our model going on the test data? We got a model performing at 95% accuracy. That's enough for me. But let's go length. So we only have 2,200 food images versus 41,000 non-food images. So that's what we're going to have to fix up. We're going to have to increase. Let's increase how many food images that we have. Food 101. Can I get the food 101 dataset in the house? Should we do that or focus on deployment first? Let's just get it working, deployed version working, and then we can build a bigger model. Dot save, food, not food, model v0. There we go. Now we can convert to TF Lite. Food, not food model v0. Saved model dir, TF Lite converter. Do we have a TensorFlow Lite model? We have a TF Lite model, ladies and gentlemen. Let's do it. Let's see if we can get this deployed now. So to get this model, do we have a timer running? Yes, we do. Okay, there's the weights and biases. Let's now go to REPL. Let's go food, not food. Going to delete. Now the classes for this will be, one is food, two is not food, I think. Let's check the order. Train data.class names. Yeah, you're so right. Isn't the baseline accuracy already 95% due to imbalance? Yes, you're right. We do need to fix this. We'll fix it in a second. Aman, thank you for that, and same with you, Arturo. Let's go class weights. We can pass the class weights. Where do we pass them? Class weights go into the fit function. Let's scale the weights. Can you all see that? Equals I'm going to scale the class for now because they're going to be different either way. Yes, that's actually right. One, so it's going to be food, non-food, and then total samples, and then we go food samples. There we go. Wait for 0 is food. Well, they're going to come in like that, aren't they? Since we have Arturo, thank you. Hey, why is this? Shouldn't they add to 1? Now, what have we got? We've got class weights. Let's see how this influences the training run. Ashik, welcome back. Good to see you, my friend. Class weights. So, adjust for different numbers of classes. So let's see how this adjusts. Do we have weights and biases tracking the history here? No thanks. Okay, they're the only ones we want to look at. We just want to only look at Splendid Dream. Let's upload weights and biases. We're going to get a new run. Okay, we're going nice and fast here, team. The Titan, Sheik, have a go at this. The Titan is training like a beast. So let's see where we can go. We've got Different Darkness, 6, and Splendid Dream. We want to see which one does better. Does the class weight affect how our model is training? Let's put a note in here. Yeah, so the class weight is changing it. It's not as performing as good. But that's what we want. Wonderful. Okay, so this model is going to be a bit more robust. And the metrics are more aligned with how the model's actually going. I'll be back. How you going with it? Okay, so this is much more reflective of how our model's going. I think we need some more food images. So we're getting about 80% accuracy. That's all right. Yogesh, how are you? Faraz, how are you? What do you mean by basics? TensorFlow course? The modeling is not too advanced. Collecting the data, we went through a fair bit to get the data because this is a custom project. So we don't necessarily have a data set ready to go. Now let's start comparing the models. Yeah, see? Splendid Dream was overfitting because we didn't adjust the class weight. Now Different Darkness, I think we need more images of food. Isn't it fun just to watch models train? Who wants to just sit here and watch this model train for a couple of minutes? No, we have things to do. So this is probably going to be our model. It's training at a very good rate, about a minute per epoch, because the class weight is adjusting the training time. Yeah, we're getting a lot of warnings here. I'd like to turn them off permanently because they're distracting. So we're getting about 80% accuracy, which is pretty good. And it's adjusted for the class imbalance. So let's save the model. And then we'll get it converted to TF Lite. will you be able to fast and stream for 10 hours? I've already had some food in this stream, and I've been drinking tea and whatnot. But I could probably fast and stream for 10 hours, yeah. Let's go to... Let's get another terminal. ls. We want to upload our food gsutil. Do I have gsutil here? Clear. Let's create another bucket. So I'm going to upload my model to Google Storage, and we have done 7 hours. We've got just over 2 hours left, team. This is beautiful. So we've got 2 hours left to deploy a model. Easy money. Console. So I'm going to create a bucket. So if you haven't used Google Cloud, that's okay. Create bucket, and let's call this food vision, food, not food. Or actually, I'm going to use one of my existing buckets so we don't have model playground. Food vision, model playground. Continue. I'm creating a Google Storage bucket because that way we can host our model on Google Storage, which will be very good. Now I can upload this to Food Vision Model Playground. Okay, ls. We're going to upload this using Google Storage. So gsutil, copy, food, not food. You're starting to see how we could script this up. v1.tf lite, gs, food vision model playground. So we got a 15 megabyte model. I reckon we can get that smaller. Who thinks we could get that smaller? We should probably do that with TensorFlow Lite model, TF Lite model maker. Because we're using the full scale ImageNet. We might want to use ImageNet Lite. Okay, so let's get that model. Thank you, Kevin. I appreciate that. I think we can do it. Let's get a smaller model building. Ashik, you're pretty confused with the Google bucket. So the Google bucket is literally just a hard drive on the internet. So rather than me going, hey, I've got this model on my local machine, and every time you go to a website, like say on your phone, and the website going to try and query my local machine, we store it on a cloud storage provider so that because there's so many, they have so many data centers around, it loads a lot faster to whatever device you're using. So rather than relying on my server here or my hard disk to upload something to the internet and then you take it, which you could do, we upload it to a centralized system, and then that way that centralized system is able to load the model faster. So yeah, that's the main reason we do that. But let's now, we're going to build a smaller model in a second. So we should have a model here. There we go, food not for food model. So it's 15 megabytes, which is probably too big for me. Under 10 megabytes is probably better. But we're gonna make this public. Public can read it. So now you should be able to download this model. So if we go to Colab, and this is what I mean. This is the reason it's public now. So you should be able to, the reason why we make it public is so that if someone visits a website and say foodnotfood.app, which is what we're building, they can download it like this. wget. So the website, when you visit it, foodnotfood.app, is going to download the model. Just like that, See how quickly that downloaded? That's the power of storing it on Google. And Amazon S3 is much the same. I think Azure call it blob storage or something like that, but that's generally what you want. So the way this is going to work is we now have, we've downloaded a data set, we've built a model, and now we're up to the deployment part. So timestamp, model deployment. Timestamp, model deployment. Let's go here. We've collected a data set. We've modeled the data set. We need to build the application. We're going to do both of these at the same time. Build and deploy. We could deploy with Gradio. Yes, you got to pay for Google storage buckets, but Google storage is very cheap. Let's have a look at this. Google storage pricing. Look at this, cloud storage. Storage is cheap online. Compute is what costs you. Pricing tables. Look at this, per gigabyte per month. So our model is 15 megabytes. So it's not even standard storage. Our model is 15 megabytes. So divide that by 100. So it's costing us 2 cents a month to store this model. You will pay some transfer fees. So when the model loads, but that's again pretty small. So right now it's costing us less than 2 cents per month. Does that make sense? Or less than 2 cents per month, because that is 2 cents per month, 2 cents per gigabyte. So that's what you need to know about Google Storage. So now it's public, but we also do need to change the CORS setting. So this is something I ran into the other day, CORS setting. CORS policy, Google Storage bucket. So cross-origin resource sharing. So, excuse me, too many bubbles in the San Pellegrino. So if you think about this from a security perspective, if I've just made this file public, and yes, you can download it, but what if someone wants to use that maliciously? So what CORS does is I can set my bucket CORS so that if you try to load this model in your own website, it won't actually work for you because I haven't approved it. So even though it's public, you can download it using wget, but you won't be able to load it in a website. Now, let me give you an example of that. So we've got to start coding an app. Food, not food. We want this. Classes, I'm going to get rid of that. Delete. So this is some code here to download a model and run inference with TensorFlow JS. So this is the only stuff. I'm not skilled in JavaScript, so this is what I prepared earlier. I'll leave links to where I got this from, but this is what's going to allow us to load TensorFlow JS. Now, if we get rid of this model, let's upload our other one before we upload file, code, food, not food. Oh, that's right. Food, not food is not local. ls. Yes, we can do this actually. So come back into here. If we run this, look what's going to happen. So TensorFlow JS is loaded. This is all this HTML does. Let me just step through this line by line. TensorFlow, so let's call this food, food, not food. Food, not food. Hello world. P. This app will tell you if the image you upload is food or not. Right? This is all it's going to do. Watch this. Kevin says JS. Oh, yes, Kevin, thank you so much. Well, I probably will have JS questions. I need to learn more about JS. See, I'm a bit more on the ML side of things, but less knowledge, well, barely any knowledge about JS. Like it took me, you don't want to know how long this took me to figure out how to write this script of loading a model and then just creating a simple button to upload an image. Took me a long time, but that's all right. And we got JavaScript's importing. Okay, I'm going to step through the HTML code first, because the way a website works is you have HTML code is going to structure things. So that's going to give you like the frame. It'll give you the title. It'll give you the text. It'll give you the button, whatnot. CSS is style, so that'll give you colorful. Right now I've got no CSS, so hence this is just text on a page, but that's my style. I'm just making literally the most bare bones app that I can. And then the JavaScript is the logic behind it. So HTML, structure, CSS, style, JavaScript is the logic behind your website. So what we want to do is the HTML, I'm just going to build it like with some plain text. Then the JavaScript is going to give us the opportunity to upload an image here. Image uploading. And then the TensorFlow JS model, TensorFlow JS package will allow us to load our TensorFlow Lite model, because TensorFlow JS is now compatible with TensorFlow Lite. Could we load a full-scale model in here using pure TensorFlow? Probably not. You do want to convert it to TensorFlow. Why? Because TensorFlow JS is going to run directly in the browser. That means that our model is going to work, rather than sending data to an API, which could be slow, it's going to work directly on whatever device you're using in the browser. So it's going to work within Google Chrome. It's going to work within Safari on an iPhone, whatever the browser is on an Android app. Yes, that's all it does. That's it. It'll tell you, it'll use a computer vision machine learning model to, does that make sense, Ashik? Let me know if you have any questions. To classify your image as food or not food. So basically, if you want to learn, we could build it through an API, but for me, that's not the best personal experience, because people often have to wait to upload data and then it has to be computed somewhere else, then it has to come back. Why not just do it on the device they're working with? Run that. And this REPL is just a website that allows you to write code and have it quickly refreshed in the browser. We could do all this locally, but I'm just doing this on REPL. So there we go. Okay, now this is not gonna, and now so if we go back through here, the HTML, we've got some upload image code. We have a label, we have an input. Input creates a button. So now I can upload a file, mushrooms. There we go, undefined, wonderful. Now it's gonna be undefined because I just changed class names in here. Food, not food. And then we have predicted class and predicted probability. And now we also have a couple of script tags here. What this script tag here tells us to do is to load, this is TensorFlow JS, right? So we load that from cdn.js deliver. CDN is content delivery network. JS deliver is like, to me, I understand it as like, it's similar to pip in Python. So JS deliver is going to give us an npm package, which is a node package. Is that correct, Kevin? So it's like loading in pandas, like pip install pandas. For me, this is like pip install TensorFlow JS, but the JavaScript equivalent version of that. Then we do the same, but for TF.js, TF Lite. So this is going to give us compatibility between TensorFlow JS and TF Lite, because that was a recent upgrade in TensorFlow. Now TF Lite models work with TF.js, or supposedly they do. And so the reason why this model works is because we've got TF Lite there. So we've got this here. But if we wanted it to load from the website, Google Storage, we could put in a URL there. So now let's do that. Okay, so npm, I don't know what npm stands for, but Kevin's saying that npm hosts JavaScript scripts as well as packages. So not necessarily pure node. So now let's try to load the model in from, I want to, maybe we go to terminal. I want to download it. So wget, do I have wget installed? Let's just get it. Okay, we've got the model now. I want to just give you an example of what's going to happen. So we downloaded the model. This is just the same model that we hosted in Google Storage. Oh, come on, man. So we've got our TensorFlow Lite model here. We've just trained that. So now there's the same one in Google Storage. If we want to copy the URL, we can do that. Go back to the REPL. Can that, can that, can that. We do need to update the cross-region origin policy. So look, there's the model code. Right, but if we add the model in here, let's see if this works. Upload file. Downloads. Oh no, code. Food, not food. We just want to get this working, and then we can go on from there. Could I learn to do deep learning projects without very expensive machine? Yes, you can. You can use Google Colab for free. npm is like pip. Yeah, yarn is basically a wrapper for npm. So now we have food, not food model, which is not going to open, of course, because it's a TF Lite model. I'm not even sure what that structure is. But now let's load in this. We'll copy the path. So we want food, not food model v1.tf Lite. So let's see if it loads the model. Model loaded. Woohoo! Look at that, team. Who's ready? Who's ready to test out the model? Yeah. So Canal, you can definitely just start with Google Colab and Kaggle. So we've got the model. Food, not food. Can H1 tags have emojis? Let's go burger. or burger, no. Run. Model loaded. Okay, we need a file. Let's get a random, what should we try? Truck. Image of a truck. Let's go. Truck is our sanity test. Oh, and we had the beautiful food that Georgia cooked us before. So I'm going to use that as the sanity test to see if this works. Truck.jpg. Upload image. We want desktop truck. Hey, where'd that truck file go? Desktop truck.jpg. We're on. Let's see. Script error. Oh, what did we get wrong? Undefined. Converting int to float 32. The bottom truck? This one? Oh, apparently, yeah. Ford have released a new truck that's electric. I heard about that. So we've got a script error. What happens if we can this and upload our truck image? Do we still have a script error? Okay, that works. Okay, we're getting a script error for this one, so there's probably something wrong here. We're not getting any outputs. When we change the model, run, what outputs do we get here? Truck. I think the image will be, our issue will be here. Let's console log something here. We got to, this is the input output type. So the error we've got here is that our model is, I'm pretty sure our model is not accepting the right type of data. int32. So we're getting an error here, undefined. Don't cast to int32. Thank you, Mintanshu. Hatan, you slept and you come back. I have just woken up to start the day and I still can't believe the goat is still writing code. I'm still here. Hey, hey, hey. Script error. So we're getting something wrong here. Let's console log the image. What does our image look like? We're doing some pre-processing code now. Okay. Float 32. You can learn, you don't need to do a master's for machine learning. You can learn it online yourself. That's how I got started. But of course, like, it's up to you. Do you learn better on your own, or do you learn better in an environment? So shape is 2, D type is float 32. So we're troubleshooting our model here. I might, if I don't get it correct, we're going to download. Okay. Let's look at this. TensorFlow Lite model inputs. Objective C. So TF Lite converter. Yes, I did. Mitanshu, I did change the labels here. Food, not food. I don't want to log the array image sync. Console log image. So we have a script error, int32. Where's int32 coming from? So our image is float 32. But the model requires converting int 32 to float 32. Whereas if we use the other model, what does that say? Warning, converting int. What D type is required by this model? I thought it was float 32. Let's try float 32. Script error. What input does TensorFlow Lite model take? So we go back to the model training code. TF float 32. ImageNet model input type is float 32. So let's go back. 420. We're gonna 420, baby. The model is erroring on the predict function. Hello from Madagascar. Hello. Mitan Shu, you're so right. The Nutrify app required uint 8. That's why the image was cast to TensorFlow. So we want... Maybe I train the model in the same way. But this is, yeah, this is strange, because see how the D type comes in here? I'm not sure why the predict function didn't work. TF Lite converter. How to check input type to TF Lite model. Uploaded model. Let's upload a model here. We're going to check what our input type is here. Food vision, food not food. Here we go. This is a cool website. Float 32. Oh, we're on. Shaking Basket, I thank you so much. You're a fantastic help. Remove all pre-processing steps and the error messages should say what shape the data is required. Handstand push-up time. We got someone else moving in here with us. Shape. What if we choose another file? Well done. So the model is buckling on the script error. And then undefined. So the output is what's buckling. Okay, we've got to move. We're going to try that in a second. All right, push-ups time. You finished? Well done. We're going to do star jumps instead of squat this time. Georgia just finished her last assessment. Well done, Georgia. But we've still got just under 2 hours left. If this doesn't work, we're going back to the TensorFlow Lite model maker. 10 punches. We'll finish off. Maybe another 5 with this. Okay. Woo! 1 backflip at the 10-hour mark. Okay. All right, let's get this deployed. See, we're running into a lot of image processing errors. Did my internet just buckle out? Oh no. Okay, we can't log the model. Jake, what's going on, my friend? Yeah, the shape's supposed to be, if we have a look at the image shape, it gets reshaped here. So if we upload, the image gets shaped into that. I don't know what's going on there. Okay, we're going back down. Let me know when you're going. Okay. I'm not sure what's going on. Let's try to recreate the same model. It's time to move on because if we want to get this deployed before the stream's over, we need to try and train it in a different way. There's something going on with the predict function, which I don't know what. But let's get rid of the truck, get rid of this. Oh wait, what was that? Load and run a okay, let's try to okay, let's try to run this. Test run TF Lite model, and if it doesn't work, we're going to go with the TensorFlow Lite model maker. Undefined, just print the output. You're so right, but I'm trying to here. Let's see. It's buckling. The model's not taking the predicted image in some way, shape, or form. Thank you.
That's okay.
Here we go. Let's try this. Wow, it's working here. Int 32. You rocking? Okay. Let's input details. It takes shape -1. D-type int 32. Int 32, let's try that. Did we try that already? Last commit was a while ago, but I'm going to commit it all at the end. Converting int 32 to float 32. Why is it converting int 32 to float 32? Last commit, let's commit some code. No need to cast. But still we're getting some sort of error here. Hey, Matanshu. What do you think's going on here? We get an int32 error. Script error. It's happening at the predict function. It's breaking here. Console, let's log this. Model about. There's something going on with the function here. Let's train another model. Let's get more data, hey? It's breaking at the predict function. Let's use TensorFlow Lite Model Maker to train a bigger model, and I'm pretty sure that'll work. So let's go get another script. Let's get more data. We want food 101. So I think I have it stored in a bucket in the TF course. Food vision, all classes. Let's go here. Okay, we're downloading more images. And in the meantime, we're going to build small model need to turn these TensorFlow warnings off. So while we're downloading some more, let's build a model with TensorFlow Lite Model Maker. Now we're just gonna, this is some code I prepared earlier. Okay, so this data is almost downloaded. You could probably wrap it in a try and accept. Guys, I really appreciate the help, by the way. Thank you so much. I'm still perplexed. UInt32, you reckon? Jake Programming says convert to UInt32. Let's see what happens. Hey. Script error. Alessandro, what's going on? Converting image to so it broke there. Oh, did I set the timer again? Yes, I did. Hari Pradul, what's going on? So we're downloading more food images to make the model better. We're going to get this to work, team. Congrats on 100K, man. Thank you so much. TensorFlow, please set your logging info to nothing. What have we got wrong here? Oh no, we've run into a CUDA error. We've got more images. Prit, hello. Sanskar, how are you? So does this still work? This still works. Come on now. Okay, we're training a model now with TensorFlow Lite Model Maker, but now we're going to build a bigger data set. So we have data, I want to unzip beautiful. These are all images of food. Need to go to the bathroom, be back. The Titan's going incredibly well. So we're inflating 100,000 food images here from the Food 101 dataset. And we're also training another model. No, I'm SSHing into my deep learning PC, which is downstairs. And I'm using that to compute. And it's taken a little while now because we're doing too many things at once on the CPU. I'm gonna get this image ready. Look at the beautiful food that Georgia made for me earlier. This is our test image. Right, this is delicious food that Georgia made earlier. So big shout out to Georgia, thank you. And we're gonna put this on the desktop. And we're going to call this food. And we need to open this up and export it. Food.jpg. There we go. This is our test. I'm all self-taught. Yes, Jake, you're right. My JavaScript skills are terrible, but my Python skills are pretty good. If you want to go to find out what I did, I created my own AI master's degree. So I just went through a whole bunch of online courses. That tells you a lot about me. And then Start AI ML is another one as well. That's how I got started. We've been doing ML for about 4 years now. So we just unraveled 100,000 images. So ls, let's upgrade the food classes to get, let's get an extra let's get an extra 20,000 data points, or an extra 30,000. Yeah, there we go. Okay, we're gonna do this. We're gonna do this very. We want to call this food not food model v2. That takes a little while to convert. We're going to let that run for a bit. So we're going to go back to our other editor. Hey, VS Code. Let's open this. Let's go to food, not food, and then go add more food images. We've got more food images to load. Balancing the datasets. So we want to, we've downloaded more data from food 101. Now to add more food images to the model. So let's get list of food 101 images. How's this going? Still exported? Oh, it's exported. Team, it's about to start raining here. We're not leaving until this is deployed. Load image. TensorFlow Keras load image. Oh, dot. It predicted non-food image more than food image. That's not good. Yeah, I wrote that. The heck Elon Musk doing here? Jake programming. Yeah, you're so right. I wrote that. Siraj Raval is a wizard. I wrote that when I first started to learn it. Since then, a few things have changed, but when I first started to learn AI, Siraj did give me a lot of inspiration. So we need more non-food images. So that's what we're going to do. I haven't done, 2017. So that's when I started. So 4 years ago. And as you can see, things change. But that's the beauty of having that article documented when it's documented. LS, okay, let's get wait. Subdir. Once again, we're doing Sir, is it a good way to solve text-to-text NLP problems by doing one-hot encoding? So, no, I would create an embedding. So, Basol, add weight. I'd look up Hugging Face NLP. Hugging Face NLP course. I'd do that. Food image paths equals, we need more food images, people. Equals, I finished milestone 1 of TF course and want to do some small CFP projects. Should I do something from scratch or use transfer learning? I'd start from scratch first and then use transfer learning to improve it. You'll probably find transfer learning works far better than from scratch. So for file in files, join. There we go. Hey, test. $102,000 images, beautiful. how to remove. I haven't created, we're not using image augmentation, no. Do I have a plan to get a master's degree? No. Have I created any course on Hugging Face? No. Use Hugging Face's standard course on their website. I've lost some weight. Hope you're. I've actually gained some weight. I'm about 5 kilos heavier than I was at the start of the year now. Okay. There we go. Food image paths. Let's get a random 10,000. Or 30,000 images. That way we've got a balanced class set. Import random. Random seed 42. We need to create a bigger data set to build a bigger model. Then we've got to man, which data set am I using? I'm using a custom data set, one from ImageNet and one from, well, about to be from Food 101. So let's go. $30K, random 30K, food image paths equals random dot sample food image paths 30,000. Okay, we have 30,000 more images, or actually let's make it 35K. That way it's closer to, what did we get for the different lengths of data sets? Let's open up model building. $41,000. So let's get an extra 38,000. So now we'll have 40,000 images of each, food and not food. Okay, now we want to so where did I do this? I did this in data splitting. Data splitting. I need to clean up this code, don't worry. I'll clean it up after the stream. There we go. Extra images. Copy images to file, image list, target dir. Okay. We just inflated our data set. Copy 3. Oops. Okay. We're copying data set. There we go. We can now build another model. Now we've got more testing data. What? Beautiful. We've got 80,000, nearly 100,000 total images now of food and not food. Let's train a model. Here we go. Okay, this is taking a longer time. But this is beautiful. Now let's go back to here. Add file. V2 of code. Did I say food not food model V2? There we go. See how this is much smaller, this model, the V2 model? But now we're also training another one, a third one. So the model made with TensorFlow Lite Model Maker is a lot smaller. Hey, did that not work? Completed. This is not the same project as the Food Vision project on ZTM course. It's close, but not the same. So see, we've reduced the model size here by 5x. That's pretty good. Now let's... going to upload the version 2 of the model and see how it goes predicting food, not food. Who's ready to go? Who's ready to make a prediction? Let's do a timestamp. Timestamp for making a prediction with Model V2. We've tried again with the TensorFlow Lite Model Maker. So this is a timestamp for version 2 of the model made with TensorFlow Lite Model Maker. Let's run this. Loaded the model. Upload model. We need script error again. There we go. What did we get? Truck, here we go. Prediction. Food, predicted probability, 100%. So I think our classes are back the front. Cause let's change this. We got a prediction here, team. Look at this, predicted class with the truck. Now if we add up a photo of food.jpg, food, predicted probability, 100%. Yeah, so okay, we need is softmax the right one to do? Sigmoid. TensorFlow JS Sigmoid. TF Sigmoid. How's our other model going? But this is working. The model is now working. Look at this. How exciting is this? We've got too much going on here. Sigmoid. What does this sigmoid give us? undefined. So let's go console log output values dot. Food. We got it working in the browser, team. How's the model code going here? Okay, this is going better. So let's go. Benjamin Cullen, what's going on? Oh, of course I'm not giving up, my friend. We need to get this model deployed. We need to get everything deployed. Let's save version 3 of the model, see if it works better. Okay, so the output, we want the argmax of 0. Maybe get So we need to fix up the output values.argmax is not a function. How do I get the argmax? What happened just before? TF argmax, okay. Let's upload image model 3 while we're here. Much better. So chicken wings works. V3 is ready to go. So let's upload model V3. And we're almost there, people. We're almost there. TF argmax is not a function. Oh, it's TF argmax. We're getting closer. So this is art array. Oh, we've got to move. We're into the final hour. But is our final model here? So I need to move. Okay. The final countdown is on. We have 10 push-ups for the final time. We're going to do 10 lunges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 kicks. 1, 2, back kick. 3. I'm going to boot this chair across the room in a second. 4, 5. Left. 1, 2, 3, 4, 5. 10 punches to finish off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Let's keep. Kevin, you've been in here the whole time. My boy. Legend Doug. Let's set one more timer. We're going to finish this. We are going to finish this. This took longer than I thought. Argmax. Okay. Why can't we get the argmax of this? Output values is not outputting. However, we get the array sync. Output 0. Let's try that. Script error. Let's block that out. Console log output. Predict, output, array sync, array sync. Output is not an array. Mitanshu, welcome back. Thank you. Okay, that's all right. That can stay there. But the output is... No, I want to get the array argmax of this. How did I calculate the... How do you turn this on to dark mode? Wrap in TF argmax. Yeah, I've got that here. Output dot array sync. Done. Output values. Hey, there we go. Halloween, baby. There we go. Argmax. So now let's add the final model, TF Lite v3. Not food. Okay, there we go. Now we can start to adjust the code. How much should we expect to earn from machine learning? It really depends. I have no idea. So now let's get rid of this. I don't want to log the output. I want to get output values. And I want to get, I need to sigmoid this probably actually. Let's try this. Is it going to predict on food? Food! Yes! Woohoo! There we go, team. We've finally predicted on food. Okay, now let's predict let's get the probability, hey? No, this should be output values should be, if we go to, let's do TF softmax. Output array sync. And then we're going to go, this equals dot argmax dot array sync. And thank you, Matan Shu. I appreciate it, my legend. And then we want output values max. Let's run. Choose file. Let's try truck. Oh, it failed again. Oh, here we go. Run. Not food, 100%. Woo! There we go. Timestamp. Timestamp 100%. Now we're going to try it on one more image, and that's the food. Predicted class food, 100%. Woo, baby. There we go, team. Okay, now let's get this onto GitHub. So we got one final step. We need to host it. We need to host it. How long do we have left? $9:42. Okay, can we get this hosted? So let's get the cause policy set for our bucket. So the cause policy allows us to download different things. ls. Do we have cause.json? Let's go here. I need to figure out where Twitch ML deploy is. All my code's everywhere. Twitch ML deploy. There we go. Cause.json. I don't want to open Xcode. Now let's go code. So we're going to make this available everywhere for an hour. We got it loaded. Pro tip, unrelated, use text content for inner text for performance. Thank you, Kevin. So if I just go text content here, boom, baby, yeah, yeah. Console log, output values, dot. Okay, we still need to deploy the model, so we need to update the cause settings of this bucket. GSU tool set cause. So the cause allows us to download the model into different platforms. Otherwise, if we don't, I'll show you what it's like without the cause. Google Storage set cause. Set cause JSON file name bucket name. So this is without setting the cause. Let me show you what happens. If we have the model as a URL, so we have the model here, we've got the URL. If we go into our code, let's get rid of some things. So we want here, if we load our model with, instead of, see how we loaded it with a string, because our model is available in the file format here. We want to load it with a Google Storage URL. Let's see what happens when we try to load it using a URL. We run, we try to load the model. It won't, it'll fail to fetch. See what I mean? So that's what happens when we try to load the model from Google Storage. But of course, we won't always have this available. So that's why we have to set the cause. Now, if we set the cause, watch what happens. Cause config.json, GS. We want to set it on this bucket. So food vision model playground. GSUtil set cause set. Now if you go GSUtil cause get, and then GS, the bucket. It should have, we can now do an hour worth of these requests from any origin with any response header. So let's have a look at what this does now. Notice how just before we had this type error failed to fetch. Now this should work if we load it from here. Run. Might take a little bit to kick in. Still failed to fetch. I thought this was going to work and it didn't work. See how we've loaded TensorFlow JS, but we haven't loaded the model? Wait. Classic. I thought this was going to work, but now it doesn't. That's all right. We'll go on Twitch ML deploy. Make sure we've got the same setup here. Type error. But if I change this, to this, it gets it. Let's try with a different photo, hey? Apple. Predicted class, not food. What? Is it just fluking now? Oh my gosh, my brain is so fried right now. Food. Predicted class, food. Okay, well it worked on that. But now it's not uploading to... I wonder if I get this model, does it work? No, it won't test. Do we get the same error? Twitch ML deploy. Last 10 mins, that's all right. We're gonna fix this. We're gonna get this done. So if I put that in there, it doesn't load either. "24-hour stream, I'll be back." For some reason, it's not loading, but that's all right. We'll fix it up. GSUtil. Why did I cut my facial hair? I felt like it. We're approaching the 10-hour mark and I'm not leaving until this is fixed. I had this working. I had something very similar working. Why did this fail to fetch? I look like a boomer with a mustache. I look like a boomer with a mustache. JS. JS deliver. TF. I need this. I don't think this will change anything, but let's see if it changes anything. I've got the latest version here. Why is the cause not working? Why is it all of a sudden have an issue when... Let's try and get it on Vercel and see what happens. Download as zip. I will get this working. Well, let's just go to local actually. Local, and we'll go We'll copy the JavaScript into here. but I actually want this form of JS. We're just copying some stuff from some code I've already written. But we're going to get this live. We're going a little bit past 10 hours. Now let's deploy and see what happens. Oh wait, we need to add the model. This is the beauty of TensorFlow Lite. The model's so small. Add the US file, JS file. I didn't add the JS file. You sure? Ah, you're right. Let's go to our trusty Vercel. Look how easy this is to deploy now, team. Vercel.com. I don't want to create a team. I have my Git repo there. It's going to deploy. Here we go. We should be deployed. Woohoo! Let's open it up. Food, not food. Model loaded. Food. Yeah! Food. Oh, it only took us the entire stream to build, but it is live. Timestamp, timestamp, timestamp the deployment. There we go. Food not food .vercel.app is live, people. Okay, now let's change the code a little to, I'm going to make it ls cause. I'm going to change this to this URL. Now, this should be able to access. We are live, people. Fully deployed. Check it out. Get gsutil cause set cause config gs. We want our bucket to be clear. And now let's change the script here to use the model from the URL and see what happens. Git add script.js, git update script to use, oh shit, git commit update script to use tf.js tf Lite model from bucket. Git push. Let's see if this does anything. Now we're going to do the real test. I need to get, let's do camera. Yeah, I got a camera that's not food, and I'll get some actual food and we'll see if we can compare. Tried it with a BK burger and it worked. Yes, and beautiful. So let me see if it works still. I've just updated the bucket. Is the model going to load from the bucket? I think we might have an issue here. It's not loading from the bucket. Awaiting TF.js model. Okay. So that's broken. I need to fix that, but that's all right. Let's get this out. It's deployed. If I don't deploy it from there, it's going to go git add script.js, git commit, revert back to using local model file, git push. Oh, I didn't save that. I need to add up the index HTML. Title is food, not food app. Git add index HTML. Update HTML title and model usage. I've just changed the title. I'm going to go get a, I'm going to go get food. Be back. So we have two options here. We have some bananas and blueberries, as you can see. I'm going to take a photo of these. The title of the web page should be updated now. And then I also have a camera. I'm going to take a photo of that. So now let me just get those over to here. Offloading it. Downloads, date modified. So here's my camera photo. I'm going to export that. Camera.jpg into food not food. And then here's my bananas and blueberries. Bananas and blueberries. Done. How's the app going? It's still working. Where is it? Food, not food. Model is loaded. There you go. There's the app. So we're going to choose a file. Food, not food. We have camera. Not food. Yeah! And then we have bananas and blueberries. Not food. Oh. Oh no. Why is that not working? Let's try it again. Let's try another image of food that I know that's food. 10 Whole Foods, train, banana. Bananas. Not food. Oh my goodness. Not food. Okay, so we need some actual food classes in the model. Food! So the model is not very good. That's all right. Let's try another class. Egg. Not food. Okay, so I think it's getting the images. We need more food images. That's going to be the fix for this. But that's enough for the stream. Let's go here. I'm going to do one more thing. Oh, hello, bananas. It's making me very hungry. Hey, look at that mustache. Happy Movember, everyone. I need to do one thing behind the scenes to really finish this app off. If you've got any chat, if you want to have any questions, we've nearly reached the end of it. Yeah, we've overfit. I got to fix that, but that's all right. We've got a simple model deployed. Hey, Arunava, how are you? So I'm doing one thing that's going to just finish up. Hot dog worked. I need to add some CSS to it. You can $77 minutes. If you want the 77-minute stuff, you can see here. I need advanced. I'm just updating something. Give me 1 second. I can't do this with my stuff on the screen. I do roll jiu-jitsu. I love jiu-jitsu. Someone says my explanation is very crazy. For my TensorFlow course, is that what you mean? an ML engineer can be called a developer, in my opinion. I'm doing a lot of developing now. Thank you, Ryan NG. I appreciate it. Been subscribed. Thank you so much. My beautiful picture of cheese worked. My computer's lagging. Tell me if I'm still live. YouTube, don't kick me off. It's right at the end. Oh my goodness. Right when we want to start loading stuff. Thank you, thank you. I'm still live. So the app is deployed. And I believe it should also be... So I'm back. Here we go. I've just started the website. foodnotfood.app. Site can't be loaded. I think it's taken a little while to propagate. But if you go to foodnotfood.app, it's live here. Is this going to work on this? It's food. Yeah, baby. Food. Yeah. All right, it's working. Okay. We're good. Food, not food. Let's try another one. Food. Yes. We are live. It's working for me. Everyone, the app's working for you. And then if we go to a new tab, if we go to foodnotfood.app, what happens here? Oh. Is it working on Safari? Foodnotfood.app. Yo, Salim, what's going on? I'm not sure why foodnotfood.app is not working. Let me go off stream for 1 second. I'd like to finish the stream with this being live. It might take about half an hour to... Beef sample is strong. A record. Host, why is this not working? Maybe it takes a little while to propagate through. It's working. Model loaded. There we go, beef. Is this food? Food! Yeah, 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 yeah! Food! Haha! Okay, team. I think that's, it works for you. Food, not food, dot app. Food, not food, dot app is working for you guys? Can anyone confirm if food, not food, dot app is working? Well, that's so strange. Thank you, Kevin, for tuning in. I really appreciate it. Let's go to food, not food. Not food dot app. Kevin, thank you so much. So this, if you guys go to this website, food, not food dot app. It's working. Okay, I got to load this. This is the final test. It's working. Haha. Food not food dot app is not working, but Vercel is working. Can we confirm? Can we confirm, is this link working? That link is working. And food not food dot app, is that working? Is this link working? Someone confirm with me, if we confirm that food not food is working in the chat, then we're done. Food not food dot app. That is crazy. It's not working for me on either device. That is insane. Okay, well, friends, thank you so much for tuning in to the 10-hour stream. This was to celebrate. For some reason, look, it's supposed to be working there, but it's not. That's amazing. We're all good. I'm even trying to load it with mobile data on my iPhone and it's not working. Let's try one more time. We're trying Google Chrome on my iPhone with mobile data. Paul is trying. Yes, foodnotfood.app lives. Everyone go to foodnotfood.app and you will test to see if your photos are of food or not. All right, that's all it does. Food, not food. Okay, I now have a totally new browser on my phone. Foodnotfood.app. I cannot believe this. I'm going to try a different device. Maybe the propagation to Australia is not working. I love how everyone in the chat is leave an issue on GitHub if it doesn't work for whatever food you're using. Foodnotfood.app. It loaded! Yes! I've got food.food.app. Food not food, baby. There we go. Okay. It's working on my iPad. Is it going to work on my iPhone now? Because these are using cellular, by the way. So, food not food. This is what the 10 hours has been leading to. Foodnotfood.app. Can confirm it's not working on an iPhone. It's working. Okay, here we go. Let's test it on these bananas. I think it doesn't like bananas. Use photo. Food! Yes, you can't see that. Okay, I need to screenshot that. And then one more. And then I'll show you then. Then we're done. So this is a camera. Use photo, not food. I'm going to screenshot that. And then I'll just show you them on the screen because I don't know how to get this stuff on here, you know. Share my iPhone screen. Let's go to there. Foodnotfood.app. This is the real life test. And all of you are using it. I'm so... Banana is a must. So yeah, please let me know leave a GitHub issue if there's any foods you want, and we'll make food not food work better. But we got it working. Food Vision is live, people. Foodnotfood.app. Go and check out foodnotfood.app. We need to update the website with foodnotfood.app. Oh. It is live. It literally, all it does is tell you that food, not food. Leave an issue if you want it fixed or if you want more foods added, and we will work on that, right? We're changing the world one food and one not food at a time. There we go. We have confirmation to finish the stream off. Please feel free if you want to look at this, foodnotfood.app. Go and visit the website. Go and go and break it. This is amazing. Thank you so much for tuning into the stream. We went all from we went from building a data set to modeling the data set. We built a data set from scratch. We built the application. We deployed the application with a live web app. We could do Gradio. We could do an API. If you want to add some styles to the website, you could leave a pull request. Please do. If anyone adds any styles to the GitHub in a pull request, I will push those changes and you will be part of the food not food revolution, okay? So if you want to style it, please style it. If you want to add some better JavaScript, because my JavaScript skills are poor, please do. make a pull request and I'll add it. But that is the 10-hour live stream. Look at that. We've finished it off. Wow. Okay, I need to go and chill out for a bit because I've been staring at a screen for 10 straight hours. But thank you so much. There'll be plenty more. The video is going to live on YouTube forever. But if you want to see future streams, I stream on Twitch as well. And you can also see streams on my archive channel. But thank you so much to the 100,000 people subscribed to this channel. I really appreciate it. There's plenty more to come. So yeah, if you want to add any code to the GitHub, go for it. Otherwise, I'm out, people. Have a good night. Have a good day wherever you are in the world. And I'll see you next time. Backflip and chill. All right, a backflip to finish. Nah, I'm kidding. See you guys. Thank you for joining in.